Imagine a spaceship unlike anything you've ever seen. No engines. No fuel tanks. No solar panels soaking up the sun's energy. Just a massive structure riding the very fabric of space itself, powered by the force of a black hole. Sounds impossible, right? But some physicists and engineers believe that, in theory, a black hole-powered spaceship could be the ultimate method of interstellar travel. No need for chemical rockets, no need for refueling, just infinite, raw power harnessed from one of the most destructive forces in the universe. But is this even remotely possible? Could we really tame a black hole and use it to propel a spacecraft across the galaxy? And if so, what kind of technology would we need? Would it be safe, or would even the slightest miscalculation rip the ship, and everyone on board, apart? To answer these questions, we need to break down everything we know about black holes, how they interact with matter and energy, and the mind-blowing physics that could make black hole starships more than just a sci-fi dream. Black holes are among the most mysterious objects in the universe. They're born when a massive star collapses under its own gravity, creating a region of space where gravity is so strong that nothing, not even light, can escape. This leads to one of the strangest paradoxes in modern physics. If nothing can escape a black hole, how could we possibly use one to generate energy? The answer lies in something called Hawking radiation, a phenomenon predicted by Stephen Hawking himself. Hawking radiation is the key to everything. According to quantum mechanics, black holes aren't completely black. Tiny pairs of particles constantly pop in and out of existence at the edge of the event horizon. Sometimes, one of these particles falls into the black hole while the other escapes, effectively stealing energy from the black hole and turning it into usable radiation. Over time, this slow leakage of energy can actually cause a black hole to evaporate. But before that happens, this radiation could, in theory, be collected and harnessed. So, how does this relate to a starship? Well, the idea is that if we could artificially create a small black hole, one just a few millimeters wide but with an immense gravitational pull, it could serve as a nearly endless power source. Some scientists have proposed that an advanced civilization could build a structure around such a black hole to capture its energy and convert it into thrust. This concept is sometimes called the black hole drive, or the Hawking drive, and it could be the most efficient method of space travel ever conceived. But the challenges are beyond anything we've ever tackled before. First, creating a black hole artificially is far beyond our current technology. It would require compressing an enormous amount of mass into an incredibly tiny space, something we can't do yet, even in our most advanced particle accelerators. Even if we could create one, keeping it stable and preventing it from either evaporating too quickly or growing uncontrollably would be an almost impossible balancing act. Then there's the issue of controlling the energy output. Hawking radiation is incredibly weak for large black holes, which means a ship using this kind of propulsion would need a very small black hole to generate enough power. But smaller black holes are also far more dangerous, as they evaporate faster and release bursts of energy that could be catastrophic if not properly managed. But let's say, hypothetically, that we solved all these problems. We figured out how to create a small black hole, contain it safely, and extract energy from it. How would this actually work as a propulsion system? Theoretically, a spacecraft could place a reflective sphere or a Dyson-like structure around the black hole, capturing the radiation it emits and directing it backward to create thrust. This would work similarly to how a rocket expels exhaust, but instead of burning fuel, it would be using the immense energy of the black hole itself. This kind of propulsion wouldn't just be powerful, it would be game-changing. A black hole starship could accelerate continuously, reaching a significant fraction of the speed of light. This means that, in theory, humans could travel to other star systems in a matter of decades instead of thousands or millions of years. But there's still another massive problem: space-time itself. Black holes don't just bend space, they twist it. Any ship using a black hole drive would have to account for the extreme distortions in space-time, which could create unpredictable gravitational effects. Navigating through this warped space would require an entirely new understanding of physics, possibly beyond Einstein's theories. And that's not even mentioning the potential risks. What if the black hole became unstable? What if the radiation levels became too high? What if, in the process of creating one, we accidentally created something we couldn't control? The idea of a black hole-powered ship is thrilling, but the dangers are just as mind-boggling. Still, some scientists argue that if an advanced alien civilization exists, they might already be using this technology. Some theories even suggest that strange gamma-ray bursts detected in deep space could be evidence of black hole-powered spacecraft accelerating through the cosmos. Of course, this is just speculation, but it raises an interesting question. If it's possible, is someone else already doing it? The implications of black hole starships go beyond just space travel. If we could truly harness a black hole's energy, it could change everything we know about energy production. No more fossil fuels. No more nuclear power. Just a limitless source of energy, drawn from the very fabric of the universe. But whether humanity will ever reach that level of technology remains an open question. For now, black hole starships remain an exciting yet distant possibility. The physics checks out in theory, but the engineering challenges are almost beyond comprehension. Still, when we look at how far we've come, from the Wright brothers to the moon landing to Mars rovers, it's hard to say what the future holds. Maybe, just maybe, one day, humanity will ride the power of a black hole to the stars. If black hole starships ever become a reality, they would fundamentally change our approach to space exploration. No longer would we be bound by the limitations of chemical rockets, which require enormous amounts of fuel to generate thrust. Instead, we'd have a nearly limitless power source that could propel us to the farthest reaches of the universe. But the deeper we dive into this concept, the more questions arise. For instance, how would we even create an artificial black hole in the first place? This is one of the biggest roadblocks to making black hole starships a reality. In nature, black holes form when massive stars collapse under their own gravity, but replicating that process artificially is beyond anything we can currently achieve. Some scientists speculate that high-energy particle collisions, like those in the Large Hadron Collider, could theoretically create microscopic black holes. But there's a catch. These black holes would be so tiny that they would evaporate almost instantly due to Hawking radiation, making them useless as a power source. To create a stable, long-lasting black hole, we need an entirely new approach. Some theories suggest that if we could compress a massive amount of matter into an extremely small space, far denser than anything we've ever worked with, we might be able to force a black hole to form. But the amount of energy required for this process is staggering, far beyond our current technological capabilities. Even if we could somehow create a black hole, we need to control it, preventing it from either growing uncontrollably or disappearing too quickly. One potential solution involves using a process called the Penrose mechanism. This idea, proposed by physicist Roger Penrose, suggests that energy can be extracted from a rotating black hole by throwing matter into it at just the right angle. The black hole's immense rotational energy could then be converted into usable power, potentially providing propulsion for a spacecraft. But implementing this on a practical level is incredibly complex. It would require precision engineering on an astronomical scale, not to mention an advanced understanding of black hole physics that we don't yet possess. And then there's the problem of radiation. Black holes are not just powerful, they are also dangerous. Any spacecraft relying on a black hole for propulsion would need to shield its crew from the intense radiation produced by Hawking radiation and other energetic processes. The heat generated by such a system would be immense, requiring advanced cooling mechanisms to prevent the ship from being destroyed by its own power source. But let's assume, for a moment, that we overcome all these obstacles. We figure out how to create and stabilize a black hole. We develop shielding strong enough to protect the crew from radiation. We build a system capable of extracting and directing energy to generate thrust. What would it be like to actually travel on a black hole starship? For one, it would be unlike any form of space travel we've ever experienced. Unlike traditional rockets, which burn fuel in controlled explosions, a black hole-powered spacecraft would generate continuous thrust, gradually accelerating over time. This means it wouldn't just reach high speeds, it could sustain them for extended periods, potentially reaching a significant fraction of the speed of light. At such speeds, time dilation becomes a serious consideration. According to Einstein's theory of relativity, time moves slower for objects traveling near the speed of light. This means that for those aboard a black hole starship, time would pass differently compared to those left behind on Earth. A journey that felt like a few years to the crew could equate to centuries passing back home. This raises profound questions about what interstellar travel would mean for humanity. Would those who leave Earth on such a journey ever be able to return to a recognizable version of their home planet? Another strange effect of traveling at such speeds is how space itself would appear to the crew. Due to relativistic effects, distant stars would seem to shift in color, appearing bluer in the direction of travel and redder behind the ship. The entire perception of the universe would be distorted, creating a surreal and potentially disorienting view of space. But let's take it one step further. What if a black hole starship didn't just use a black hole for propulsion, but as a means of bending space-time itself? Some theories suggest that if we could manipulate a black hole's gravitational field correctly, we might be able to create a warp drive, essentially bending space around the ship to allow for faster-than-light travel. This concept, inspired by the Alcubierre drive theory, involves contracting space in front of the ship and expanding it behind, effectively allowing the ship to move faster than light without violating the laws of physics. Could black holes be the key to unlocking this kind of travel? Some scientists believe it's possible. The intense gravitational effects of black holes could, in theory, be harnessed to warp space in ways we don't yet fully understand. If so, black hole starships might not just be a means of traveling through space. They could be a way to manipulate space itself, opening the door to faster-than-light travel and making intergalactic exploration a reality. Of course, all of this remains in the realm of theoretical physics for now. We are still centuries, if not millennia, away from having the technology to build and control a black hole-powered spacecraft. But the fact that these ideas are even being discussed shows just how far our understanding of the universe has come. And there's one more possibility to consider. What if black hole starships already exist? If an advanced alien civilization has been around for millions or even billions of years longer than us, they might have already developed this technology. Some astronomers speculate that unexplained bursts of high-energy radiation observed in deep space could be the signatures of alien spacecraft using black hole propulsion. While there's no solid evidence to support this idea, it's a tantalizing possibility that raises even bigger questions about our place in the universe. If we ever do encounter evidence of such technology, it would mean that black hole starships are not just a theoretical possibility, but a practical reality for more advanced civilizations. And if that's the case, it might only be a matter of time before humanity follows in their footsteps, unlocking the power of black holes and taking our first real steps into the wider universe. If black hole starships were to become a reality, they wouldn't just revolutionize space travel. They would redefine the way we think about energy, engineering, and the very nature of human civilization. Imagine a world where the greatest limitation to interstellar travel, fuel, was no longer an issue. Traditional rockets require enormous amounts of propellant to push against the vacuum of space, but a black hole-powered spacecraft would have a nearly inexhaustible energy source. One of the most intriguing concepts tied to black hole propulsion is the idea of the Hawking drive. This theoretical engine, first proposed by physicist Lewis Crane and others, would use the radiation emitted by a tiny black hole to produce thrust. Unlike conventional engines, which rely on chemical or nuclear reactions, a Hawking drive would harness the fundamental forces of the universe itself. The idea is deceptively simple. Small black holes, which constantly emit Hawking radiation, could serve as a source of highly energetic particles. These particles could then be directed out of the spacecraft in a controlled manner, producing continuous acceleration. But controlling this radiation is no small feat. Black holes, by their nature, are incredibly dangerous objects. Even a small one, no more massive than a mountain, would still exert an immense gravitational pull. If the black hole were too massive, it could pose a risk to the ship itself, potentially pulling it in and destroying everything on board. On the other hand, if it were too small, it would evaporate too quickly, making it useless as a long-term power source. One of the biggest questions surrounding black hole starships is how they would be created in the first place. Naturally occurring black holes are typically formed when massive stars collapse under their own gravity, but these objects are far too large to be practical for space travel. Theoretically, we could create artificial black holes through high-energy particle collisions, similar to what happens in the Large Hadron Collider but on an even greater scale. However, the energy requirements for this would be staggering. Some estimates suggest that to create a stable, usable black hole, we would need to compress the mass of an entire asteroid into a space smaller than an atomic nucleus. The amount of energy needed for such a process is beyond anything humanity can currently produce. Even if we found a way to create and stabilize an artificial black hole, another major challenge would be containment. The gravitational pull of a black hole is immense, and keeping it confined within a spacecraft without it pulling in surrounding matter, including the ship itself, would require an entirely new level of engineering. Some theories suggest that powerful electromagnetic fields could be used to trap the black hole and prevent it from interacting with the ship's structure, but this remains purely speculative. Let's say, for a moment, that we figure out how to overcome these challenges. We build a black hole-powered starship, one that can sustain propulsion for decades or even centuries. What would space travel actually look like with such a system? First, the acceleration capabilities of a black hole engine could be unlike anything we've ever seen. Because the engine could theoretically run indefinitely, a black hole starship wouldn't just reach high speeds, it would sustain them. Over time, this means that the ship could approach relativistic speeds, meaning a significant fraction of the speed of light. At these speeds, strange relativistic effects come into play. The ship's crew would experience time much more slowly than people back on Earth. A journey that felt like a few years to the travelers could translate into centuries passing for those left behind. But what if we could go even further? Some scientists have speculated that, in addition to propulsion, black holes could also be used as a means of bending space itself. This ties into the idea of wormholes, hypothetical shortcuts through spacetime that could allow for near-instantaneous travel between distant points in the universe. While wormholes remain purely theoretical, some physicists believe that black holes could play a role in their creation. If this were true, a sufficiently advanced civilization could potentially harness black holes not just as engines, but as gateways to other parts of the cosmos. This leads us to one of the most mind-bending possibilities. What if other civilizations have already mastered this technology? The Fermi paradox asks a simple but profound question. If the universe is so vast, where are all the aliens? One possible answer is that advanced civilizations may have already discovered black hole propulsion and are using it to travel between stars in ways we don't yet understand. Some astronomers have even speculated that certain unexplained cosmic phenomena, such as bursts of high-energy radiation, could be the signatures of alien starships using black hole technology. If we ever do discover evidence of such technology, it would change everything. It would mean that black hole starships are not just a theoretical possibility, but a practical reality for advanced civilizations. And if that's the case, it might only be a matter of time before humanity follows in their footsteps, unlocking the power of black holes and taking our first real steps into the wider universe. But perhaps the most fascinating thing about this entire concept is that it forces us to think differently about our place in the cosmos. Black hole starships, if they ever become a reality, would not just be a means of traveling between planets or even between stars. They would represent a fundamental shift in how we interact with the universe. They would give us access to energies and forces that, until now, have been the domain of nature itself. And what if we go even further? If we can build black hole starships, could we eventually learn to manipulate black holes in even more advanced ways? Could we harness them to create entire artificial worlds, powered by miniature black holes? Could we use them to generate nearly limitless energy, ending our reliance on fossil fuels or even traditional nuclear power? The implications are staggering. But for now, black hole starships remain in the realm of theoretical physics. We are still centuries, if not millennia, away from having the technology to build and control a black hole-powered spacecraft. Yet the fact that these ideas are even being considered shows just how far our understanding of the universe has come. The question isn't whether black hole starships are possible, it's whether we will one day be able to build them. And if we do, it could mark the beginning of a new era, one where humanity is no longer confined to a single planet, a single solar system, or even a single galaxy. It could be the first step toward becoming a truly interstellar species. If black hole starships ever become a reality, they wouldn't just be a means of transportation. They would represent one of the most profound technological revolutions in history, an entirely new way of interacting with the universe itself. The ability to harness a black hole's energy, contain it, and use it for controlled propulsion would mean that humanity had not only mastered one of nature's most mysterious forces but had also surpassed the fundamental limitations that have always restricted our ability to explore space. One of the most interesting aspects of black hole propulsion is the sheer efficiency of the process. Conventional rockets expend enormous amounts of energy to generate thrust, often requiring massive fuel reserves that limit their range. A black hole starship, on the other hand, could continuously produce energy through Hawking radiation. Because this radiation is emitted due to quantum effects at the event horizon, it means that energy is essentially being extracted directly from the black hole itself. Unlike chemical rockets, which burn fuel and eject mass, a Hawking-drive spaceship could maintain thrust indefinitely without consuming external resources. This leads to an interesting question: how fast could a black hole starship actually go? If we assume that the black hole's Hawking radiation is being used to generate thrust in an optimized manner, the ship could, in theory, continue accelerating for years or even centuries. This means it could eventually reach speeds close to the speed of light. At these velocities, the effects of special relativity become impossible to ignore. The closer a ship gets to light speed, the more time slows down for those on board compared to observers on Earth. A journey to another star system that might take thousands of years in normal time could feel like just a few years to the crew. This raises profound implications for interstellar travel. If a civilization could successfully build and sustain black hole starships, they could theoretically explore the galaxy within a single lifetime from the perspective of the travelers. However, due to time dilation, thousands or even millions of years might pass for those left behind on their home planet. This could lead to situations where space travelers return to their homeworld only to find that entire civilizations have risen and fallen in their absence. But what about the risks? Black holes are among the most dangerous objects in the universe. If a black hole-powered ship lost control of its containment field, even for a moment, the consequences could be catastrophic. The black hole could consume parts of the ship, or worse, begin to pull in nearby matter uncontrollably. Even a small, artificial black hole, if left unchecked, could cause unimaginable destruction. This means that any civilization attempting to use this technology would need to develop containment systems of unparalleled precision. One proposed method of containment involves using extremely powerful magnetic fields to hold the black hole in place. These fields would prevent it from drifting toward the ship's structure while also directing its radiation output in a controlled manner. The problem is that such containment systems would need to be incredibly strong and stable over long periods. Even a slight fluctuation in the magnetic field could result in disaster. Another challenge is heat management. Black hole starships would generate immense amounts of energy, and unless that heat was properly dissipated, it could destroy the ship itself. Traditional spacecraft rely on radiators to release excess heat into space, but a ship powered by a miniature black hole would require a much more sophisticated cooling system to survive long-term journeys. This brings up an interesting point. What if black hole propulsion is already being used by advanced extraterrestrial civilizations? Some astronomers have speculated that high-energy cosmic phenomena, such as unexplained gamma-ray bursts, could actually be the exhaust signatures of alien spacecraft using black hole technology. While this remains purely speculative, it raises the possibility that if intelligent life exists elsewhere in the universe, they may have already mastered this form of propulsion. If we ever detect such signals, it could provide indirect evidence of extraterrestrial engineering on a massive scale. It could also mean that black hole starships are not just a theoretical concept but a reality that has already been achieved by civilizations far older and more advanced than our own. And if that's the case, then what comes next for us? Humanity has always been driven by curiosity, by a need to push boundaries and explore new frontiers. The development of black hole starships would represent the ultimate expression of this desire. The ability to leave our solar system behind and travel across the cosmos with virtually no limits. The history of technological advancement is filled with examples of discoveries that were initially seen as beneficial but later revealed their darker consequences. The development of nuclear energy, for example, led to both clean electricity and the creation of devastating weapons. The mastery of black hole technology could lead to incredible progress, but it could also pose existential risks if used irresponsibly. What happens if a rogue group or an unstable government gains control of black hole technology? Could black holes be weaponized? Could they be used to create artificial singularities that threaten entire planetary systems? The potential dangers are as vast as the possibilities. Some futurists have even speculated that the reason we haven't detected intelligent extraterrestrial life may be because civilizations tend to self-destruct once they reach a certain level of technological advancement. If black hole propulsion is truly possible, then we must ensure that we use it wisely. Otherwise, we risk becoming just another failed civilization that reached too far, too fast, and was ultimately undone by its own ambition. And yet, despite the risks, the dream of black hole starships remains one of the most tantalizing possibilities in modern physics. If we ever master this technology, it could open the door to an entirely new era of human history, one in which we are no longer bound to a single planet, or even a single star system. Perhaps, one day, the first black hole starship will launch from Earth, setting out on a journey that will take it across the galaxy. Perhaps future generations will look back on this moment as the turning point when humanity truly became a space-faring species. The road ahead is uncertain, but one thing is clear: the mysteries of space still hold secrets that we are only beginning to uncover. And black hole starships may be one of the most profound mysteries of them all. If black hole starships ever become a reality, they would redefine the very essence of space travel. Right now, our understanding of interstellar travel is severely limited by fuel constraints, propulsion efficiency, and the sheer distances involved. But black hole propulsion offers something unprecedented: nearly limitless energy, the ability to sustain thrust indefinitely, and the potential to reach relativistic speeds. However, before we even think about building such a spacecraft, we need to understand the incredible physics behind it. At the heart of a black hole starship is the concept of Hawking radiation. Stephen Hawking proposed that black holes aren't entirely black. They emit radiation due to quantum effects near their event horizon. This happens because of virtual particle pairs that constantly pop in and out of existence due to the uncertainty principle. Normally, these particle pairs annihilate each other almost instantly. But near the event horizon of a black hole, one particle can fall into the black hole while the other escapes as Rio radiation. This process slowly drains the black hole's mass and converts it into energy. For a black hole starship, this energy source is both a blessing and a challenge. On one hand, it means the ship wouldn't need external fuel like traditional spacecraft. On the other hand, it means we would need to contain, control, and extract energy from a tiny artificial black hole without letting it destroy the ship. That's no small task. To understand just how challenging this is, consider the power levels involved. A black hole with the mass of a mountain, around 10 to the power of 12 kg, would radiate about 160 petawatts of power, far more than the entire energy consumption of human civilization. If we could harness even a fraction of that energy, it would be more than enough to power an interstellar spacecraft. The problem is controlling it. One theoretical design for a black hole starship is the black hole battery concept, where the radiation from a small black hole is converted into thrust using mirrors or electromagnetic fields. This idea takes advantage of the fact that Hawking radiation is emitted in all directions. By carefully shaping the surrounding containment structure, we could direct this radiation backward, generating forward momentum. But where would we get an artificial black hole? creating one in a laboratory is far beyond our current capabilities. The most likely method would involve high-energy particle collisions at a scale far greater than anything we can achieve today. Some theories suggest that the Large Hadron Collider, LHC, or future particle accelerators could, under the right conditions, create microscopic black holes. However, these would evaporate almost instantly due to Hawking radiation, making them useless for propulsion. Instead, a more viable option might be to search for naturally occurring small black holes, primordial black holes that may have formed in the early universe. These would be much smaller than stellar mass black holes, making them ideal candidates for controlled energy extraction. If we could capture and stabilize one of these black holes, we could theoretically use it as the power source for a starship. However, stabilizing a black hole is easier said than done. The immense gravitational forces involved would require containment fields beyond anything we currently understand. Even the slightest instability could cause the black hole to drift out of control, potentially consuming part of the spacecraft or creating dangerous gravitational distortions. One possible solution involves using negative energy, an exotic form of matter predicted by quantum field theory. Negative energy has the strange property of counteracting gravity, potentially allowing us to suspend a black hole in a stable position. This concept ties into ideas like the Alcubierre warp drive, which proposes that negative energy could be used to bend spacetime itself. If we could generate and manipulate negative energy, we might be able to create a stable framework around a black hole, allowing us to use it for propulsion safely. However, negative energy remains highly theoretical, with no confirmed way to produce it in large quantities. Until we unlock this mystery, containing a black hole remains one of the biggest obstacles to building a black hole starship. But let's assume for a moment that we solve these technical challenges. What would a journey on a black hole starship actually look like? Unlike conventional spacecraft, which rely on short bursts of acceleration followed by long periods of coasting, a black hole starship could accelerate continuously. This means it could gradually build up to incredible speeds, potentially reaching a significant fraction of the speed of light. At these speeds, time dilation would become a major factor. For the passengers on board, time would slow down dramatically compared to the outside universe. A trip that might take thousands of years from an external observer's perspective could feel like just a few years for those aboard the ship. This effect has profound implications for space exploration. It means that even distant galaxies, which seem completely out of reach by today's standards, could be accessible to a civilization that masters black hole propulsion. But time dilation also comes with a cost. The crew of a black hole starship might return from their journey to find that centuries or even millennia have passed on their home planet. If they were exploring a distant star system, they might come back to find that their entire civilization has changed, or even disappeared. This raises profound philosophical and ethical questions. If interstellar travel at near-light speeds becomes possible, would travelers still consider themselves part of the society they left behind? Or would they become something entirely different, a new kind of human, adapted to life on a relativistic starship? There's also the question of communication. Because information can't travel faster than light, messages sent back to Earth from a black hole starship would take years or even decades to arrive. This means that space travelers would be effectively cut off from their homeworld, forced to operate independently in a universe where real-time communication is impossible. Some scientists have proposed using quantum entanglement to overcome this limitation. In theory, entangled particles could allow for instantaneous communication across vast distances. However, quantum entanglement doesn't allow for faster-than-light information transfer, at least not with our current understanding of physics. So, if black hole starships become a reality, they could usher in a new era of space exploration, but they would also come with profound challenges. The ability to harness a black hole's power would give us access to virtually unlimited energy, but it would also require technologies that are far beyond anything we currently possess. If we ever succeed in building such a spacecraft, it could fundamentally change the course of human history. Instead of being confined to our solar system, we could travel to other stars, explore distant galaxies, and perhaps even encounter other intelligent civilizations. But one thing is certain: mastering black hole propulsion would be one of the greatest scientific and engineering feats ever achieved. And if we do achieve it, it could mark the beginning of a new era, one where humanity is no longer bound to a single world but instead becomes a true interstellar species. If black hole starships become a reality, one of the most significant breakthroughs will be our ability to manipulate and control an entity that defies common intuition. A black hole is not just an object, it's an extreme distortion of space-time. Its gravitational pull is so intense that nothing, not even light, can escape from within its event horizon. But outside that event horizon, black holes interact with their surroundings in ways that we might be able to harness for propulsion. The idea of using a black hole as a power source is based on the concept that black holes radiate energy. This radiation, known as Hawking radiation, is usually associated with the slow evaporation of black holes over immense timescales. However, if we can capture and direct this energy output, it could serve as an efficient means of propulsion. The fundamental challenge is to find a way to keep the black hole stable, extract energy from it without being consumed by its gravitational pull, and convert that energy into controlled thrust. One of the most promising theoretical designs involves placing a black hole inside an engineered containment structure. This structure would have to be incredibly strong, able to resist the immense gravitational forces exerted by the black hole while allowing energy to be extracted in a useful form. A concept often proposed in scientific literature is a spherical array of mirrors or energy collectors that could redirect the emitted Hawking radiation. These mirrors would act like a parabolic dish, focusing the radiation in a single direction to generate thrust. The sheer complexity of this system is mind-boggling. The containment field, assuming we could create one, would need to be dynamically adjusted to ensure the black hole remains centered. Any deviation could lead to catastrophic failure, as an uncontrolled black hole could destabilize the entire spacecraft. It would need to be held in place by an artificial gravity well or some form of repulsive force, possibly using exotic matter with negative energy properties, something that remains purely theoretical at this point. Beyond containment, another challenge is determining the most efficient way to convert Hawking radiation into usable thrust. One method might involve using a heat exchanger, where emitted radiation is absorbed by a working fluid that expands and drives a turbine. This is similar in principle to how nuclear reactors generate electricity, but at a vastly higher energy scale. Another possibility is to use electromagnetic fields to guide and accelerate emitted particles in a controlled direction, creating a propulsion effect similar to an ion drive but with far greater energy output. Once we solve the propulsion challenge, another issue emerges: navigating through space while dealing with the effects of extreme gravity. A black hole generates intense gravitational fields, which means that the surrounding space is curved in ways that could make traditional navigation methods ineffective. The ship would have to account for gravitational distortions constantly, using advanced computational models to plot courses that compensate for relativistic effects. At relativistic speeds, time dilation becomes a significant factor. A crew aboard a black hole starship traveling at near light speed would experience time at a different rate compared to stationary observers. For example, a journey that feels like a few years on board could correspond to centuries or even millennia passing on Earth. This means that long-term space travelers might return to find that civilization as they knew it no longer exists. This raises another important consideration: how would humanity handle the psychological and societal effects of such long-duration space travel? Would travelers be willing to leave everything behind, knowing that their journey might outlive their home civilization? This is a question that has been explored in science fiction but remains unanswered in reality. Communication would also be a major obstacle. Because information cannot travel faster than light, any messages sent back to Earth would experience significant delays, making real-time communication impossible. This means that black hole starships would need to operate with a high degree of autonomy, potentially relying on advanced AI systems to make real-time decisions without input from Earth. One speculative idea is that quantum entanglement could be used to establish instantaneous communication, bypassing the speed of light limitation. However, While quantum entanglement allows for instantaneous correlations between entangled particles, it does not provide a method for transmitting usable information faster than light. This means that, as far as we know, any communication with a black hole starship would still be subject to light speed delays. Another major question is, what happens if something goes wrong? If a black hole containment failure were to occur, the results could be catastrophic. An uncontrolled black hole could consume the ship itself, or worse, become a danger to any nearby celestial bodies. This is why any attempt to use black hole propulsion would require fail-safes of the highest order. One possible fail-safe might be to design the system in such a way that, if containment is lost, the black hole is ejected safely into deep space, where it poses no immediate threat. If humanity ever achieves the ability to build black hole starships, the implications would be profound. It would mean that interstellar travel is no longer limited by chemical propulsion, nuclear reactions, or even antimatter. We would have access to an energy source capable of sustaining acceleration for decades or centuries, allowing us to travel vast distances in relatively short subjective time frames. This could open the door to colonizing exoplanets, exploring distant galaxies, and potentially encountering extraterrestrial civilizations. However, the journey to developing such technology is filled with unknowns. Right now, we lack the fundamental scientific breakthroughs necessary to manipulate black holes safely. But the pursuit of this knowledge could lead to discoveries that reshape our understanding of physics. Whether or not black hole starships ever become a reality, the quest to explore such possibilities pushes the boundaries of human ingenuity and scientific exploration. And if one day we do manage to harness the power of a black hole, it could mark the beginning of a new era, one where humanity is no longer confined to a single planet, or even a single star system, but instead spreads across the cosmos as an interstellar civilization. If we ever manage to construct a black hole starship, it wouldn't just revolutionize space travel, it would fundamentally change our understanding of technology, energy, and even survival in deep space. The implications of such a breakthrough extend far beyond propulsion. They touch on how civilizations could harness extreme physics to thrive among the stars. But before diving into what life aboard a black hole starship would look like, we have to consider something even more challenging: how to create or acquire a black hole in the first place. One of the most perplexing challenges in this idea is that black holes don't just appear on demand. They are formed from the collapse of massive stars, and the smallest ones, called stellar mass black holes, are still far too large for practical space travel. A black hole with the mass of a star would exert gravitational forces that could tear apart anything nearby, making it impossible to control. Instead, we would need an artificial black hole, something much smaller, yet still powerful enough to generate the energy needed for propulsion. This leads to a fascinating question: can we create a black hole ourselves? Some theories suggest that if we could compress a sufficient amount of mass into an incredibly small space, we could artificially generate a micro black hole. However, the energy required to do this is beyond anything we can currently achieve. The Large Hadron Collider, LHC, the most powerful particle accelerator on Earth, can generate extremely high-energy collisions, but not nearly enough to create a black hole. Even if it could, these black holes would be so tiny that they would evaporate almost instantly due to Hawking radiation. So, if creating a black hole from scratch is impractical, the next best option might be to capture an existing one. But how do you capture something that devours everything in its vicinity? The idea of catching a black hole might seem absurd, but if a primordial black hole, a theoretical remnant from the early universe, were to be found drifting through space, we might be able to enclose it within a containment structure before it falls into a star or gets lost in interstellar space. If we could obtain or generate a stable, small black hole, we would still need to develop the necessary technology to harness its power. This is where the concept of an energy extraction system comes into play. Scientists have proposed several theoretical mechanisms that could allow us to extract energy from black holes. One of the most well-known is the Penrose process, which suggests that objects falling into a rotating black hole could extract some of its rotational energy before being ejected. If we could set up a system where matter is fed into the black hole in a controlled way, we could theoretically convert some of that energy into usable thrust. Another potential energy source is the Blandford's-Nagic process, which involves magnetic fields extracting energy from a spinning black hole. If a black hole were surrounded by a disk of charged particles and strong magnetic fields, it could generate powerful jets of energy. These jets could be redirected to provide thrust, turning the black hole into a propulsion system. This method, while theoretical, has some basis in astrophysical observations. Many supermassive black holes in the centers of galaxies emit enormous jets of plasma, suggesting that this process does occur in nature. But even if we could successfully harness energy from a black hole, one major problem remains: radiation. Black holes emit intense radiation, especially when they are actively consuming matter. This radiation could be lethal to any nearby passengers or equipment. Shielding a spacecraft from such radiation would require materials that can absorb or deflect high-energy emissions without being destroyed in the process. One proposed solution is to use electromagnetic fields to create a protective barrier, similar to Earth's magnetic field shielding us from solar radiation. However, generating a field strong enough to protect a spaceship would require an immense amount of power. Assuming we solve these technical hurdles, what would life aboard a black hole starship actually look like? Unlike traditional spacecraft, which rely on fuel that eventually runs out, a black hole propulsion system could, in theory, provide continuous acceleration for decades or even centuries. This means that a black hole starship wouldn't just be a vehicle, it would be a self-sustaining world, carrying generations of travelers as they explore the cosmos. Given the extreme nature of such a journey, passengers and crew would have to adapt to an environment unlike anything ever experienced. Time dilation effects would mean that while years might pass on board, centuries could pass for those back on Earth. This could create profound psychological and social challenges. Entire generations could live and die aboard the ship, never knowing what has become of humanity back home. Additionally, the ship would have to be entirely self-sufficient. This means producing its own food, recycling air and water, and maintaining artificial gravity to prevent the long-term health issues associated with weightlessness. Advanced biospheres, similar to the ones being researched today for potential Mars colonization, might be necessary to sustain a stable environment for human life. One particularly intriguing aspect of black hole starships is that, given enough energy and the right conditions, they might be able to bend space-time itself. Some theories suggest that if a black hole could be manipulated with enough precision, it could create a controlled warp bubble, essentially allowing faster-than-light travel without violating the laws of physics. This idea, while speculative, is reminiscent of the Alcubierre drive, a theoretical propulsion system that compresses space in front of a ship while expanding it behind, effectively allowing faster-than-light movement without breaking the speed limits set by relativity. Of course, before we can even think about warping spacetime, we need to answer fundamental questions about how black holes behave. Our current understanding is based largely on indirect observations and theoretical models. We have never interacted with a black hole up close, and much of what we know about them could change as new discoveries are made. Future telescopes, deep space probes, or even experiments with artificial gravity fields might give us the insights we need to move beyond speculation. But if black hole starships ever become a reality, they could change the course of human history in ways we can't yet imagine. They could allow us to explore distant galaxies, establish interstellar colonies, and perhaps even uncover the deepest mysteries of the universe. And if we do find a way to harness the power of a black hole, it might just be the key to becoming a truly spacefaring civilization. The concept of a black hole starship challenges the very limits of engineering, physics, and even human endurance. If we could successfully build one, the entire nature of space travel would change forever. No longer would we be limited by chemical rockets or nuclear propulsion. Instead, we would have access to a nearly limitless energy source. Theoretically, this could enable us to travel not just across the Milky Way, but between galaxies, crossing cosmic distances that, today, seem utterly impossible. But to truly understand the scale of what we're discussing, we have to ask an even deeper question: what does it actually mean to harness a black hole? To answer this, we need to consider the extreme nature of these objects. A black hole is, in essence, pure gravity, an entity so dense that nothing, not even light, can escape from within its event horizon. But outside this point of no return, physics still applies. A rotating black hole, known as a Kerr black hole, drags spacetime around with it in a process called frame dragging. If we could somehow tether a spacecraft to this region without falling in, we could tap into this rotational energy, extracting it for propulsion. One possible method involves deploying a massive ring or set of orbiting satellites around the black hole. These satellites could harvest energy from the surrounding disk of superheated matter falling into the black hole, similar to how we harness energy from stars using solar panels. The heat and radiation emitted from the accretion disk could be converted into usable power, providing an almost inexhaustible energy source. But managing such an environment would be extraordinarily difficult. The temperatures around an active black hole can reach millions of degrees, meaning any spacecraft operating in this region would need revolutionary heat-resistant materials and cooling systems. Even more intriguing is the possibility of using Hawking radiation, the theoretical process by which black holes slowly evaporate, to generate energy. According to physicist Stephen Hawking, black holes emit tiny amounts of thermal radiation due to quantum effects at the event horizon. If we could somehow amplify this effect, we could create a highly efficient power source. The idea of using Hawking radiation as a form of propulsion is speculative, but if it proves feasible, it could allow us to control the lifespan of a black hole, ensuring that it remains stable enough to power a starship indefinitely. But how do you control something as unpredictable as a black hole? The idea of steering a black hole sounds impossible, but in theory, there are ways to influence its movement. One possibility is using gravitational interactions. If we could precisely control the flow of matter falling into the black hole, we might be able to manipulate its trajectory, nudging it in specific directions. This would require incredibly precise calculations, as even the slightest miscalculation could send the black hole drifting off course, making the entire starship uncontrollable. If we could solve these problems, what kind of missions would a black hole starship undertake? One of the most obvious applications would be interstellar exploration. With a virtually unlimited energy source, such a ship could travel to distant star systems without worrying about refueling. It could carry large numbers of passengers, scientific equipment, and even entire ecosystems, acting as a mobile colony capable of sustaining human life for centuries. Another possibility is time dilation research. Because black holes warp spacetime, they provide a unique opportunity to study the effects of extreme relativity. A spacecraft orbiting close to a black hole would experience time much more slowly than the rest of the universe. This means that scientists aboard the ship could witness cosmic events unfolding at an accelerated rate, seeing stars form and die in what would feel like just a few years to them. This could offer unprecedented insights into astrophysics, cosmology, and the ultimate fate of the universe. But perhaps the most mind-bending possibility is the idea of using a black hole for actual time travel. Some physicists believe that if a black hole is connected to a hypothetical wormhole, it could allow for shortcuts through spacetime. If this is true, a black hole starship could become more than just a vehicle. It could be a gateway to different parts of the universe, or even different points in time. The problem, of course, is that we have no idea if any of this is actually possible. The physics of black holes is still not fully understood, and many of these ideas remain highly speculative. But even if a black hole starship remains out of reach for now, the mere fact that we can conceive of such a thing is a testament to human ingenuity. Throughout history, many technologies that once seemed impossible, flight, space travel, quantum computing, eventually became reality. The same could be true for black hole propulsion. So, will we ever build a black hole starship? Right now, the answer is uncertain. But one thing is clear: if we ever do, it will mark the beginning of a new era for humanity. It will mean that we have truly mastered the forces of the cosmos, unlocking the ability to travel not just among the stars, but perhaps even beyond the limits of space and time itself. The sheer ambition of a black hole starship makes it one of the most challenging engineering projects imaginable. But if we break it down step by step, it becomes a question of how we can interact with, harness, and control one of the most extreme objects in the universe. The first problem is how to even acquire a black hole in the first place. There are two main approaches: finding a naturally occurring black hole and attempting to create an artificial one. The first option presents several problems. Most black holes are located light years away from Earth, making them incredibly difficult to reach with our current technology. Even if we manage to get close to one, approaching a black hole without getting torn apart by tidal forces or bombarded by intense radiation is another massive challenge. This is where the second option comes in: creating our own black hole. According to theoretical physics, if we could compress enough mass into an incredibly small volume, we could create a black hole artificially. One way to do this would be to use particle accelerators far more powerful than anything we have today. If we could collide particles at energies trillions of times greater than what the Large Hadron Collider can achieve, we might be able to create micro black holes. These would be tiny black holes, perhaps no larger than an atom, but they would still possess the same gravitational properties as their larger counterparts. The key challenge is keeping such a black hole stable. If it's too small, it would evaporate almost instantly due to Hawking radiation. If it's too large, it might become difficult to control, posing a potential threat to its surroundings. The ideal solution would be to create a black hole of just the right size, large enough to provide useful energy, but small enough to be manageable. Scientists have proposed using highly advanced electromagnetic fields or even futuristic gravity cages to contain such an object. These fields would prevent the black hole from interacting uncontrollably with its environment, while still allowing us to extract energy from it. Once we have a stable black hole, the next challenge is extracting energy from it efficiently. There are several methods we could use. One possibility is the Penrose process, which takes advantage of the fact that rotating black holes have an ergosphere, a region outside the event horizon where objects can still escape but experience extreme frame dragging. If we send a spacecraft or object into this region in a specific way, it can be slingshot out with more energy than it originally had, effectively stealing rotational energy from the black hole. Another method involves using electromagnetic fields to extract power from the intense radiation produced by the accretion disk. This approach would work similarly to how solar panels convert sunlight into electricity, but instead of sunlight, we would be capturing energy from the superheated plasma swirling around the black hole. The third method is the most exotic: harnessing Hawking radiation itself. If we could construct a system capable of collecting and redirecting this radiation, we could theoretically use it as a highly efficient power source. The challenge here is that Hawking radiation is incredibly weak for large black holes, meaning we would need to engineer a black hole of precisely the right mass to make it a viable energy source. With an efficient way to extract energy, we now face perhaps the most difficult challenge of all: propulsion. How do you move a black hole starship through space? Traditional propulsion methods, such as chemical rockets or ion drives, wouldn't be enough to move an object of such enormous mass. Instead, we would need to manipulate the black hole itself. One possible approach involves feeding the black hole a controlled stream of matter in such a way that it emits energy in a preferred direction, creating thrust. This would function similarly to how a rocket expels exhaust, but on an entirely different level. Another idea is to use powerful gravitational interactions to steer the black hole by carefully adjusting the trajectory of objects falling into it. This would be incredibly complex, requiring precise calculations to ensure the black hole moves in the desired direction without destabilizing the ship. If we could overcome these challenges, a black hole starship would be capable of truly unprecedented feats. Not only would it allow for interstellar travel, but it could potentially travel between galaxies. Unlike conventional starships, which would require enormous amounts of fuel to sustain their journey, a black hole ship would have a virtually unlimited power supply. This means it could sustain a civilization aboard it indefinitely, effectively turning it into a self-sufficient generational ship. The time dilation effects near a black hole also open up incredible possibilities. Astronauts traveling aboard such a ship could experience time differently from those on Earth, potentially witnessing the evolution of entire galaxies in what would feel like just a few decades to them. This could provide invaluable scientific insights into the long-term development of the universe, allowing us to observe cosmic phenomena that would otherwise take millions or even billions of years to unfold. But the most intriguing possibility is the potential for faster-than-light travel using black hole physics. Some scientists speculate that if we could manipulate the space-time distortions caused by a black hole, we might be able to create a form of warp drive. The idea is based on the concept that space itself can be stretched and contracted, allowing a spacecraft to effectively ride a wave of space-time without actually breaking the speed of light. If this turns out to be possible, a black hole starship could be the first vehicle capable of traversing vast cosmic distances in a fraction of the time it would take using conventional methods. Despite all these exciting possibilities, there are still many unanswered questions. Would the immense gravitational forces of a black hole cause unforeseen problems for a ship orbiting nearby? Could we really maintain a stable artificial black hole, or would it eventually spiral out of control? Would the radiation emitted by the black hole be too dangerous for human passengers, even with advanced shielding? These are questions that will require decades, if not centuries, of research to answer. Ultimately, the dream of a black hole starship represents the pinnacle of human ambition. It is the ultimate challenge, one that forces us to push the boundaries of science, engineering, and imagination. If we ever succeed in building one, it will be the most profound achievement in the history of our civilization, opening the door to a future where humanity is no longer confined to a single planet, or even a single galaxy. It would mark the beginning of a new era, one in which we become true masters of the cosmos, capable of harnessing the most powerful forces in the universe to propel us into the unknown. Even if a black hole starship remains in the realm of science fiction for now, the theoretical groundwork for such a concept is slowly being laid. Physicists and engineers continue to explore ideas that might one day make this seemingly impossible vision a reality. One of the most promising areas of research is the study of quantum gravity, which seeks to unify our understanding of black holes with the fundamental laws of physics. Currently, our best theories of black holes come from general relativity, which describes how massive objects warp spacetime. However, general relativity doesn't fully explain what happens inside a black hole, especially at its singularity, the point where density becomes infinite. To truly understand and manipulate black holes, we need a complete theory of quantum gravity, something that has eluded scientists for decades. String theory and loop quantum gravity are two competing models that attempt to bridge this gap. String theory suggests that all particles and forces, including gravity, are made up of tiny vibrating strings. If this is true, it could provide insights into how black holes function on a microscopic scale. Meanwhile, loop quantum gravity proposes that spacetime itself is made up of discrete loops, which could help explain how black holes form, evolve, and possibly be controlled. Another crucial area of research involves exotic materials and energy sources. If we ever hope to build a structure capable of surviving near a black hole, it will need to be made of materials far beyond what we currently have. We might need ultra-dense matter, possibly even materials stabilized by quantum effects, to withstand the extreme gravitational and radiation forces present in such an environment. One potential candidate is degenerate matter, which is found in neutron stars. This material is so dense that a sugar cube-sized amount would weigh billions of tons. If we could develop artificial structures made from similar materials, they might be strong enough to operate near a black hole without being torn apart. However, strength alone isn't enough. We also need a way to counteract the immense radiation emitted by the black hole's accretion disk. This is where advanced electromagnetic shielding comes into play. Future starships might be equipped with magnetic fields strong enough to deflect harmful radiation, similar to how Earth's magnetic field protects us from solar wind. But even if we solve these engineering challenges, there's still the question of how to interact with a black hole in a controlled way. Could we develop some kind of artificial intelligence capable of piloting a ship around a black hole with precision? Would we need entirely new forms of computation, perhaps even quantum computers, to process the immense gravitational calculations required for navigation? These questions highlight just how far we still have to go before a black hole starship becomes reality. But one thing is certain: if we can ever harness the power of black holes, the possibilities for humanity will be limitless. It could allow us to travel between the stars, establish civilizations in distant galaxies, and even unlock entirely new forms of energy production. Some scientists even speculate that black holes could hold the key to understanding the true nature of the universe itself. If we could study them up close, we might finally answer questions about the nature of time, the limits of physics, and whether alternate universes exist beyond our own. For now, the black hole starship remains a dream. But every great achievement in human history, from the first flight to the moon landing, began as an idea that seemed impossible. If we continue pushing the boundaries of science, who knows what the future may hold? Perhaps one day, a black hole starship will carry humanity beyond the stars, into a future we can scarcely imagine. If a black hole starship were ever built, the implications would go far beyond just interstellar travel. It would redefine humanity's relationship with energy, physics, and even time itself. The sheer power of a black hole would provide an almost limitless source of energy, potentially surpassing anything we've ever conceived. But could we actually harness and control such power? And what would happen if we did? One of the biggest challenges of space travel today is propulsion. Rockets require immense amounts of fuel, and even the most advanced propulsion systems, like ion thrusters, struggle to achieve the speeds necessary for interstellar journeys. But a black hole could, in theory, provide a completely different kind of propulsion, one that doesn't rely on fuel in the traditional sense. One proposed method involves using the relativistic jets emitted by a spinning black hole. As matter falls into a black hole's accretion disk, it gets heated to extreme temperatures and emits massive amounts of energy. Some of this energy is ejected in the form of highly focused jets moving at nearly the speed of light. If a spacecraft could position itself within this jet and use it as a propulsion system, it could accelerate to relativistic speeds, potentially reaching other star systems in a fraction of the time it would take with conventional propulsion. But how would a starship actually navigate around a black hole? The gravitational pull of a black hole is so extreme that even light bends around it. To control a starship near a black hole, we would need an entirely new understanding of orbital mechanics. Instead of flying in straight lines or simple orbits, a black hole starship would have to weave through complex gravitational fields, using techniques that today exist only in theory. One possibility is the halo orbit, where a spacecraft could orbit just outside the event horizon, using the immense gravitational forces to slingshot itself at incredible speeds. This could allow for rapid acceleration without using much energy, similar to how current spacecraft use planetary flybys to gain momentum. However, the precision required for such a maneuver would be astronomical. A tiny miscalculation could send the ship spiraling toward destruction. Another potential propulsion method is the black hole drive, which involves collecting Hawking radiation. Stephen Hawking predicted that black holes slowly evaporate over time, emitting tiny amounts of radiation. If a spacecraft could capture and harness this radiation efficiently, it could theoretically generate a continuous thrust. While the energy output would be small, it could be enough to sustain long-duration space travel over centuries or even millennia. But let's assume, for a moment, that we figure out all these technical challenges. We build a ship capable of traveling around black holes, harvesting their energy, and using them as cosmic highways. What then? What would happen if we actually sent a crewed mission to explore a black hole up close? Time dilation is one of the strangest effects of black holes. According to Einstein's theory of relativity, time moves slower in stronger gravitational fields. Near a black hole, time could slow down dramatically, so much so that a crew spending just a few years near a black hole could return to find that centuries or even millennia have passed on Earth. This creates a paradox. Would a black hole starship become a kind of one-way time machine, separating travelers from the rest of humanity forever? This raises another question. What if a civilization already figured out how to use black holes for travel? Could advanced extraterrestrial beings be using black holes as cosmic highways, moving between galaxies in ways we can't yet understand? Some scientists speculate that black holes could serve as natural waypoints for an interstellar civilization, allowing them to hop between distant regions of space without ever needing traditional fuel. If true, this could explain some of the mysterious signals we detect from deep space. Fast radio bursts, strange emissions from black holes, and even the odd behavior of certain cosmic objects could, in theory, be the result of alien civilizations using black holes for travel. While there's no concrete evidence for this idea, it remains one of the most fascinating possibilities in modern astrophysics. Yet, there's also a darker side to the concept of black hole starships. What if something goes wrong? If humanity ever developed the technology to create artificial black holes, or even manipulate existing ones, the consequences could be catastrophic. A miscalculation could lead to a black hole consuming an entire planet. A malfunctioning ship could become a runaway singularity, swallowing everything in its path. The risks are enormous, but so are the potential rewards. For now, black hole starships remain a vision of the far future. But every great leap in human history once seemed impossible. The idea of airplanes, moon landings, and even harnessing nuclear energy were once dismissed as science fiction. Yet, through perseverance and innovation, humanity has continued to push the boundaries of what is possible. If black hole starships ever become a reality, they won't just change how we travel, they'll change how we see the universe. They could allow us to reach distant galaxies, explore the deepest mysteries of space-time, and perhaps even discover new dimensions of existence. The universe is vast, and black holes are among its greatest enigmas. If we can unlock their secrets, who knows what awaits us on the other side? The possibility of using black holes for space travel also brings up profound philosophical and existential questions. If we could harness the immense power of black holes to travel across the cosmos, what would that mean for the future of humanity? Would we become a multigalactic species, no longer bound by the limitations of our solar system? Or would we, in our quest for knowledge and exploration, inadvertently create dangers that we cannot control? The idea of black hole travel is deeply tied to the mysteries of physics that we still don't fully understand. Black holes challenge our current understanding of the universe, bending the very fabric of space and time in ways that defy conventional logic. If we could manipulate black holes for propulsion, we might also gain new insights into the nature of reality itself. Could this lead us to a deeper understanding of quantum gravity, the unification of general relativity and quantum mechanics? Could it even reveal new forces of nature that we have yet to discover? One of the most compelling ideas in modern physics is that black holes might not just be destructive forces but also gateways to other regions of space, or even other universes. Some theories suggest that black holes could be connected through Einstein-Rosen bridges, better known as wormholes. If this is true, then black hole starships might not just be a means of moving within our own galaxy. They could provide access to entirely new realms of existence. But the problem with using wormholes is that, as far as we know, they are incredibly unstable. A naturally occurring wormhole, if it exists, would likely collapse in an instant. However, some physicists speculate that if we could stabilize a wormhole, perhaps with exotic matter that possesses negative energy, it might remain open long enough for a spacecraft to pass through. If that were possible, black holes wouldn't just be engines of propulsion, they could be cosmic doorways, allowing us to step into distant parts of the universe in the blink of an eye. Even if wormhole travel proves impossible, black holes still hold another intriguing possibility: using them as energy sources. Black holes store unimaginable amounts of energy, and if we could develop the technology to extract it efficiently, we could power entire civilizations. This idea is central to the concept of a Type 3 civilization on the Kardashev scale, a theoretical civilization capable of harnessing the energy of entire galaxies. A civilization advanced enough to manipulate black holes could potentially generate power on a scale far beyond anything we can currently conceive. One proposed method of energy extraction involves the Penrose process, named after physicist Roger Penrose. In this process, A spacecraft could send an object into the ergosphere of a rotating black hole, where space itself is dragged along by the black hole's immense spin. If the object splits in two, one part falls into the black hole while the other escapes with more energy than it originally had. This process could, in theory, be used to extract energy from a black hole indefinitely, providing a limitless power source for a future spacefaring civilization. Another concept, known as the Blandford's-Nagic process, suggests that energy could be harvested from the magnetic field surrounding a black hole. If a sufficiently advanced civilization could manipulate these fields, they could convert the rotational energy of a black hole into usable power. This could be used to fuel interstellar missions or even sustain entire artificial worlds orbiting black holes, similar to the speculative idea of a black hole Dyson sphere. The idea of civilizations living near black holes is a fascinating one. While black holes are often seen as dangerous, inhospitable places, there are theories suggesting that they could be ideal locations for advanced life forms. A civilization with the ability to harness a black hole's energy could build massive space stations or even entire artificial planets in stable orbits around the event horizon. These structures could exist in a state of time dilation, where time moves slower relative to the rest of the universe. This would allow inhabitants to experience centuries while the outside universe ages by millennia. Such civilizations might already exist somewhere in the universe, hidden from our detection. Since black holes don't emit light, any advanced civilization living near one would be extremely difficult to observe. Could some of the unexplained cosmic signals we detect be the result of black hole civilizations? Could highly advanced extraterrestrials be using black holes not just for travel, but as homes, power sources, and even communication hubs? If black hole starships ever become a reality, they would completely redefine our approach to space travel. Traditional spacecraft rely on chemical or nuclear propulsion, but black hole starships would be able to achieve near-light speeds without the need for conventional fuel. They could operate indefinitely, powered by the gravitational and quantum forces of the universe itself. This could allow humanity to spread across the cosmos, reaching distant star systems and even other galaxies within a single lifetime. But there's one final mystery we haven't yet discussed. What happens if a spacecraft ventures too close to a black hole? Could we ever build a starship that can survive the extreme tidal forces of the event horizon? According to our current understanding of physics, anything that crosses the event horizon of a black hole is lost forever. But some theories suggest that there may be ways to escape, or that the inside of a black hole might not be what we expect. One controversial idea is the concept of firewalls at the event horizon. Some physicists believe that the event horizon of a black hole might not be a smooth, invisible boundary but instead a searing wall of energy that would instantly destroy anything that tries to pass through. If this is true, then black hole travel might be far more dangerous than we imagined. Another theory, however, suggests that black holes could act as cosmic tunnels leading to other parts of the universe. If a spacecraft could somehow survive the intense gravity and radiation, it might emerge in a completely different region of space, or even in another universe entirely. If this is true, then black holes might not be the ultimate destroyers we think they are. Instead, they could be natural portals, allowing civilizations to travel across cosmic distances beyond anything we can currently imagine. Whether or not black hole starships ever become a reality, the mysteries surrounding black holes will continue to captivate scientists and explorers alike. They represent some of the most extreme and fascinating phenomena in the universe, challenging our understanding of physics, time, and space itself. If we ever unlock their secrets, we may find that they are not just objects of destruction, but gateways to the greatest adventures in human history. But even if black holes turn out to be completely hostile to human travel, their influence on space exploration is undeniable. The more we learn about black holes, the more we realize they are not just passive remnants of dead stars. They actively shape galaxies, influence cosmic structures, and could be crucial in developing the next generation of spacefaring technology. One of the most promising ideas involves using black holes as gravitational slingshots for interstellar travel. We already use a similar method within our own solar system, where spacecraft like Voyager 1 and 2 gain speed by using the gravity of planets. A black hole's immense gravity could, in theory, be used to accelerate a spacecraft to incredible speeds, potentially even approaching the speed of light. If we could precisely navigate a spacecraft around a rotating black hole, we might be able to harness its energy to propel us far beyond the limitations of traditional propulsion systems. But even if we don't use black holes as direct engines, they could still serve as interstellar weapons. Advanced civilizations might build space stations or refueling depots around black holes, using their gravitational pull to stabilize long-term human presence in deep space. If we ever become a Type 3 civilization on the Kardashev scale, black holes will almost certainly play a role in our survival and expansion. Some physicists even suggest that black holes might hold the key to faster-than-light travel. While Einstein's theory of relativity tells us that nothing can travel faster than light, some speculative theories propose that space itself could be manipulated. If a civilization could harness the exotic physics surrounding black holes, they might be able to create warp bubbles, bending spacetime in a way that allows them to bypass the speed limit imposed by relativity. This idea connects to the Alcubierre drive, a hypothetical faster-than-light propulsion system proposed by physicist Miguel Alcubierre. His equations suggest that, rather than moving through space, a spacecraft could contract space in front of it and expand space behind it. If black holes could be used to generate the exotic energy needed for such a drive, they might hold the key to achieving interstellar travel far beyond what we currently believe is possible. Of course, all of this is highly speculative, and we are still a long way from having the technology to manipulate black holes in any meaningful way. But the fact that we are even considering these possibilities speaks to the incredible advancements we have made in understanding the universe. Just a century ago, black holes were purely theoretical constructs. Today, we have direct evidence of their existence, and we are actively studying them using telescopes like the Event Horizon Telescope, which produced the first-ever image of a black hole in 2019. But with every new discovery comes new questions. Could there be different types of black holes that we haven't yet detected? Could there be black holes that behave in ways we don't expect? Some physicists propose that there may be primordial black holes, left over from the early universe, which could be incredibly small but still pack an immense gravitational punch. Others suggest that there might be black holes that are actually naked singularities, where the singularity is exposed rather than hidden behind an event horizon. If these exotic black holes exist, they might offer entirely new ways of thinking about space travel. Perhaps small, artificial black holes could be created and controlled, serving as energy sources or even propulsion systems. Some theories suggest that if we could manufacture a microscopic black hole and carefully contain it, we could use its Hawking radiation as a nearly infinite energy supply. This idea leads to another mind-bending possibility. What if black holes could be used for computing? Quantum computers are already being developed on Earth, but some physicists believe that black holes might be the ultimate quantum computers, capable of processing information in ways we can barely comprehend. If a sufficiently advanced civilization could harness black holes as computational devices, they might achieve levels of intelligence and problem-solving ability beyond anything we can imagine. And what about the idea that we ourselves could be living inside a black hole? Some cosmologists have proposed that our universe might actually exist inside the event horizon of a larger black hole in another universe. If this is true, then black holes might not just be objects within our universe. They could be the very fabric of reality itself. All of these ideas bring us back to the core mystery of black holes, their ability to bend and shape the very laws of physics. If we ever hope to use black holes for space travel, we will first need to understand the fundamental nature of space, time, and gravity. And as we continue to push the boundaries of our knowledge, we may find that black holes are not just obstacles to overcome, but the key to unlocking the deepest secrets of the cosmos. If black holes are the key to unlocking deep space travel, then the biggest challenge is figuring out how to survive near them. The closer you get to the event horizon, the stronger the gravitational pull becomes, and for any object with mass, escaping would be impossible. But scientists have proposed ways we might work around this, at least in theory. One idea is using carefully calculated orbits that allow a spacecraft to enter a stable trajectory around a black hole without falling in. A rapidly spinning black hole, known as a curved black hole, could, in theory, allow objects to orbit at extreme speeds. This could be useful for gaining momentum or harnessing energy. However, the problem of time dilation remains. If astronauts were to orbit too close, time would slow down for them relative to the rest of the universe. This means that even a short trip near a black hole could result in returning to find that centuries or even millennia have passed elsewhere. But what if we could take advantage of this time warping effect? Some have speculated that black holes could serve as time vaults for preserving information or even life itself. If an advanced civilization wanted to survive into the far future, it could place itself in orbit around a black hole, effectively slowing down time while the rest of the universe aged around it. This would be an extreme form of time travel, one that doesn't allow you to go backward, but lets you leap forward into the distant future. Another fascinating possibility is the idea of wormholes. While black holes are known for pulling things in and never letting them escape, some physicists believe that under certain conditions, a black hole could be connected to another part of space via a wormhole. If this were true, black holes wouldn't just be dangerous cosmic traps. They could be gateways to other star systems, galaxies, or even parallel universes. The concept of wormholes has been explored in physics for decades, particularly in Einstein-Rosen bridge theory. This idea suggests that if space can be curved to form a tunnel-like structure, matter could theoretically travel through it and emerge somewhere else. However, there's a major problem. Wormholes, if they exist, are likely to be unstable. The moment anything enters, the tunnel could collapse, crushing anything inside. Some theories suggest that exotic matter, hypothetical particles with negative energy, could stabilize a wormhole and prevent it from collapsing. If an advanced civilization had control over exotic matter, they could theoretically create a stable passage through a black hole, making intergalactic travel possible in an instant. This is still entirely speculative, but it raises an interesting question. If black holes are naturally occurring, could there already be stable wormholes hidden among them? This idea ties into the Fermi paradox, the question of why we haven't detected extraterrestrial civilizations despite the vastness of the universe. Some researchers suggest that advanced civilizations might be using black holes as highways across space, traveling in ways we can't detect. If a civilization could manipulate black holes, they might be completely invisible to our current methods of observation. But what if there's an even more extreme way to use black holes? Some scientists have proposed that an ultra-advanced civilization could actually construct black holes as tools for energy generation. This would be the ultimate form of power, a civilization creating and controlling black holes to extract their energy. This idea aligns with the concept of a Type 3 civilization on the Kardashev scale, one that can manipulate the energy of an entire galaxy. If such civilizations exist, they would likely be so advanced that we might not even recognize their technology as artificial. Some astrophysicists have even speculated that certain unexplained cosmic phenomena, such as fast radio bursts or strange objects emitting unusual energy signatures, might be evidence of civilizations using black hole technology in ways we don't yet understand. And then there's the wildest possibility of all. Could an advanced civilization upload its consciousness into a black hole? If black holes are capable of storing vast amounts of information, as some theories suggest, then in a distant future, intelligent beings might transfer their minds into black holes, effectively achieving a form of digital immortality. If information is never truly lost in a black hole, as recent research suggests, then this could be the ultimate archive, a cosmic database where civilizations preserve their knowledge for eternity. All of this brings us to an important realization. Black holes are not just cosmic anomalies to be feared. They may be the foundation for the next stage of human evolution in space. Whether we learn to travel around them, harness their energy, or even use them to leap into the far future, they are likely to play a key role in our journey to becoming a space-faring civilization. As we continue to study black holes, we may find answers to some of the biggest questions in physics, questions about space, time, and the nature of reality itself. But perhaps the most exciting possibility is that black holes could one day become not just obstacles to overcome, but tools that help us explore the universe in ways we can't yet imagine. If black holes are truly the key to the future of space travel, then the next step is figuring out how to harness their power without being destroyed in the process. The idea of using black holes as energy sources isn't entirely science fiction, it's based on real physics. One of the most well-known concepts for extracting energy from a black hole is the Penrose process, first proposed by physicist Roger Penrose in 1969. The idea is that a spacecraft could enter a region around a rotating black hole known as the ergosphere, where space-time itself is dragged along due to the intense spin. If an object were to split in two within this zone, one part falling into the black hole and the other escaping, then the escaping object would actually gain more energy than it had initially. This means that, in theory, a civilization could extract massive amounts of energy from black holes simply by carefully using their rotational momentum. But what if we could take this concept even further? Enter the Blandford's-Nagic process, a more advanced theoretical model that suggests a black hole's powerful magnetic fields could be used to extract energy more efficiently. This is particularly relevant for quasars, the most luminous objects in the universe, powered by supermassive black holes at the centers of galaxies. These objects emit energy at a scale so vast that some scientists believe an advanced civilization could build megastructures around them to harness their output. One extreme idea is the concept of a Dyson sphere around a black hole, a megastructure designed to capture energy not from a star, but from the radiation and jets emitted by an actively feeding black hole. While this might seem impossible for us now, a Type 2 or Type 3 civilization on the Kardashev scale could, in theory, construct such a structure to supply unlimited energy for space travel, computation, and even artificial intelligence far beyond our current understanding. But let's push this idea even further. What if we could build an actual starship powered by a black hole? This concept, known as the black hole starship, is one of the most ambitious ideas ever proposed for interstellar travel. The idea is that if we could somehow create or capture a small black hole, we could use Hawking radiation, the slow evaporation of black holes predicted by Stephen Hawking, to generate thrust. The physics behind this is fascinating. Small black holes evaporate faster than large ones, releasing high-energy particles as they shrink. If a spacecraft could contain this radiation and direct it for propulsion, it could create an ultra-efficient drive system capable of reaching near light speeds. A black hole starship wouldn't rely on traditional fuel. It would be powered by the fundamental laws of physics themselves. However, this comes with enormous challenges. First, we would need to create a black hole small enough to be used for this purpose. Theoretical models suggest that microscopic black holes, on the order of 100,000 tons, could be stable and produce enough radiation to be useful. But where would we get one? One possibility is that we might engineer a black hole using high-energy particle collisions far beyond anything we can achieve today. Another idea is that small black holes might already exist, left over from the early universe. If we could locate one and harness it, we wouldn't need to create one from scratch. Once we have a black hole, the next challenge is containment. How do you stop a black hole from falling through your spaceship and destroying everything in its path? Some proposals suggest that electromagnetic fields could be used to stabilize a small black hole in the center of a spacecraft, preventing it from drifting. However, this would require technology far beyond what we currently possess. But the potential benefits of black hole starships are enormous. A spacecraft powered by Hawking radiation could, in theory, travel at relativistic speeds, meaning that time dilation effects would come into play. A crew traveling on such a ship might experience just a few years while centuries pass for those left behind on Earth. This means that black hole starships could be the best way to reach distant star systems within a human lifetime, even if the journey takes thousands of years from an outside perspective. There's also the possibility of using black holes as natural accelerators. If a spaceship were to carefully navigate the gravitational pull of a rotating black hole, it could use what's known as the slingshot effect to gain incredible speeds. This is already done with spacecraft using planets like Jupiter for gravity assists, but with a black hole, the energy boost would be on an entirely different scale. And here's where things get even stranger. Some physicists have speculated that black holes might not just be gravitational wells, they could be gateways to other parts of the universe. If the right conditions exist, a black hole could be linked to a white hole, an object that expels matter instead of absorbing it. This is a purely theoretical concept, but if white holes exist, they could provide a way to instantly travel vast distances, perhaps even between galaxies. Some scientists have even suggested that our own universe could be inside a black hole. If this is true, then black holes might not just be points of destruction, but bridges between realities, with each black hole creating a new universe within it. If we ever learn to manipulate these cosmic structures, we might not just explore the stars, we might discover entirely new realms of existence. All of this raises a mind-bending question. Has another civilization already figured this out? If black hole starships are possible, then any advanced alien race capable of building them might already be using them to travel the universe in ways we can't even detect. Some researchers have suggested that highly advanced species might be living near black holes, using their immense energy output as a power source. If so, these civilizations might be completely invisible to us, hidden in the warping effects of space-time itself. The idea that black holes could be the ultimate tool for space exploration is one of the most exciting possibilities in modern physics. Whether through energy extraction, artificial black holes, or even the manipulation of space-time itself, black holes could one day help us travel to the farthest reaches of the cosmos. But for now, they remain one of the greatest mysteries in the universe, a mystery that, if solved, could redefine our place in the cosmos forever. If black holes hold the key to future space travel, then the next step is figuring out how to take advantage of them without being destroyed in the process. The idea of harnessing black holes for energy and propulsion is not entirely science fiction, it is based on real physics. But turning these theoretical ideas into actual technology is an enormous challenge, one that requires breakthroughs in multiple areas of science. One of the most fundamental problems with using black holes for space travel is that they are extremely difficult to interact with. A black hole is essentially a region of space where gravity is so strong that nothing, not even light, can escape once it crosses the event horizon. This makes it impossible to directly extract anything from inside the event horizon. However, there are several ways to use the surrounding environment of a black hole to extract energy, generate propulsion, or even manipulate space-time itself. One potential method of harnessing energy from a black hole is through accretion disks. When matter falls toward a black hole, it forms a swirling disk of superheated plasma around the event horizon. The friction and intense gravitational forces in this disk generate massive amounts of radiation, including X-rays and gamma rays. If a spacecraft were to position itself near this disk, it could theoretically collect this radiation and convert it into usable energy. This is similar to how solar panels collect sunlight, but on a much more extreme scale. But this method has limitations. First, the temperatures near an accretion disk are incredibly high, reaching millions of degrees. Any material exposed to this environment would need to withstand extreme heat and radiation. Second, the intense gravitational forces could make it difficult to maintain a stable orbit without being pulled into the black hole. A more advanced method of using black holes for space travel is based on Hawking radiation. As mentioned earlier, Stephen Hawking predicted that black holes are not completely black. They slowly emit radiation due to quantum effects near the event horizon. This process causes the black hole to gradually lose mass and eventually evaporate. If we could create or capture a small black hole, we could use this radiation as a power source. A black hole starship could theoretically be powered by Hawking radiation thrust, where a spacecraft contains a small black hole and directs the emitted radiation in a controlled way to produce thrust. However, this idea presents major challenges. First, we would need a way to create or capture a small black hole. The Large Hadron Collider, the most powerful particle accelerator on Earth, is nowhere near strong enough to create a black hole of the necessary size. We would need an accelerator many orders of magnitude more powerful. Even if we had a small black hole, the next problem is containment. Unlike a traditional engine, which burns fuel, a black hole engine would need to be carefully contained using advanced gravitational or electromagnetic fields. If the black hole were to drift out of position, it could easily destroy the ship. Despite these challenges, black hole starships remain one of the most intriguing possibilities for interstellar travel. Unlike traditional propulsion systems, which require carrying massive amounts of fuel, a black hole starship could generate energy continuously for thousands or even millions of years. This makes it ideal for long-term space travel, where refueling is impossible. Another possibility is using black hole gravitational assists to accelerate spacecraft. Just as we use planets like Jupiter to slingshot spacecraft to higher speeds, a spacecraft could theoretically use the immense gravity of a black hole to gain enormous amounts of momentum. However, this would require extreme precision. Getting too close could result in being pulled past the event horizon with no hope of escape. Perhaps the most mind-bending idea is that black holes might not just be useful for propulsion, they could be gateways to other parts of the universe. Some theories suggest that black holes could be connected to wormholes, which are hypothetical tunnels through spacetime that could allow instantaneous travel between distant points in the universe. If true, then a sufficiently advanced civilization might be able to use black holes as natural shortcuts through space, allowing them to travel across the galaxy without needing to move at relativistic speeds. But the idea of wormholes comes with its own set of challenges. First, most models suggest that wormholes would be highly unstable, collapsing almost immediately after forming. Second, even if a stable wormhole existed, the intense tidal forces near its entrance could rip apart anything trying to pass through. Some physicists have proposed that exotic matter, a form of matter with negative energy, could be used to stabilize wormholes, but no such material has ever been observed in nature. Still, the idea that black holes could be the key to interstellar travel remains one of the most exciting possibilities in modern physics. If we ever learn to manipulate these cosmic structures, we might not just explore the stars, we might discover entirely new realms of existence. Black hole starships might sound like pure science fiction, but the physics behind them is real. The problem is turning these theories into practical technology. Even if we assume that in the far future, humanity has the capability to create or harness black holes, the next question is, how do we actually build a working spacecraft around one? The challenges are monumental, but they aren't necessarily impossible. One of the biggest issues is stability and control. A black hole is an object of unimaginable mass and gravity, which means that anything near it is going to experience extreme tidal forces. If a spacecraft were to get too close, the difference in gravitational pull between the front and the back of the ship could literally stretch it apart. This effect is known as spaghettification, and it's one of the reasons why getting close to black holes is so dangerous. For a black hole-powered spacecraft to work, it would need a way to contain the black hole at a safe distance while still being able to extract energy from it. One potential method is using a system of high-energy electromagnetic fields to create an artificial containment zone. In some futuristic models, the black hole is suspended in a special structure, where its gravitational influence is carefully balanced so it doesn't pull the ship apart. However, such technology is far beyond anything we currently possess. Another issue is fueling the black hole. Black holes don't just generate energy on their own, they need matter to consume. If a spacecraft is using an artificial black hole as its power source, it would need a way to constantly feed it. Theoretically, the ship could carry a supply of matter, such as hydrogen or other dense materials, that it drops into the black hole as needed. This matter would be converted into energy through the process of Hawking radiation or accretion disk emissions. However, there's an efficiency problem. Even though black holes are incredibly powerful, not all of the matter that falls into them gets converted into energy. A significant portion simply vanishes beyond the event horizon, lost forever. This means that a black hole engine would need to be extremely efficient in how it collects and uses the emitted radiation. One alternative approach is to use a rotating black hole, also known as a Kerr black hole, to extract energy more effectively. Kerr black holes spin at incredible speeds, and according to some theories, it's possible to extract energy from their rotation using a process called the Penrose process. This involves sending an object into the region just outside the event horizon, where it can split apart. One part falls into the black hole, while the other is flung away with more energy than it started with. In theory, a spacecraft could use this effect to gain momentum without needing to burn fuel. But this brings up another problem: radiation hazards. The area around a black hole is filled with intense radiation, from X-rays to gamma rays. This kind of radiation is deadly to humans and could easily fry electronic systems. Any spacecraft that gets close to a black hole would need extreme shielding to protect itself. One idea is to use plasma shields or electromagnetic barriers to deflect high-energy particles before they reach the ship. However, creating such shielding on a large scale is still beyond our capabilities. Despite all these challenges, the potential rewards of black hole starships are immense. A black hole-powered spacecraft wouldn't need traditional fuel, and it could theoretically sustain itself for millions of years. This makes it the perfect candidate for deep space exploration, where carrying fuel for a conventional engine would be impractical. If humanity ever hopes to travel to distant stars, or even other galaxies, then black hole starships might be one of the only viable solutions. Even more mind-boggling is the idea that black holes could be used as natural space-time shortcuts. Some physicists have suggested that certain types of black holes, if they connect to wormholes, could allow faster-than-light travel. If true, this would completely revolutionize space exploration, allowing us to reach distant points in the universe almost instantly. However, as mentioned before, the problem is stability. Most wormhole models suggest that they would collapse too quickly for anything to travel through. But what if an advanced civilization has already figured it out? Some scientists have speculated that if an alien species had millions or even billions of years of technological advancement, they might have found a way to stabilize and use black holes for interstellar travel. Some theories even suggest that supermassive black holes, like the ones found at the center of galaxies, might act as intergalactic highways for advanced civilizations. If that's the case, then it raises an even deeper question: could black holes themselves be artificial? This might sound like pure science fiction, but some physicists have speculated that extremely advanced civilizations might have the ability to engineer black holes for energy generation or travel. In other words, what if some of the black holes we see in the universe aren't natural at all, but are instead remnants of ancient starfaring civilizations? While we have no direct evidence for this idea, it's a fascinating concept. If we ever develop the technology to explore black holes up close, we might discover that they are far more than just cosmic anomalies. They might be the key to unlocking the ultimate mysteries of space and time. If black holes are more than just natural cosmic phenomena, if they are, in some way, engineered or harnessed, then the implications for space travel are beyond anything we can currently comprehend. It could mean that the universe is filled with hidden structures, massive black hole starships or artificial singularities that serve as transit points for civilizations far more advanced than ours. This concept is known as the Black Hole Transit Network, where black holes could act as cosmic highways, allowing civilizations to travel vast distances with minimal energy expenditure. But if black holes are being used in this way, how would we detect them? The reality is, we might not be able to. A black hole starship, one that uses a black hole for propulsion, would be almost invisible to our current telescopes. Unlike a conventional spaceship that burns fuel and emits heat or light, a black hole-powered craft would primarily emit radiation from Hawking radiation or accretion disk emissions, both of which are incredibly difficult to detect against the backdrop of space. This leads to another mind-bending possibility. What if some of the black holes we've already discovered aren't just naturally occurring, but are actually moving? Some astrophysicists have suggested that rogue black holes drifting through space without a host galaxy, could actually be artificial. These objects might be traveling at speeds that don't quite match the expected motion of naturally formed black holes. If this is the case, then we might already be observing alien megastructures, but because they appear as black holes, we simply don't recognize them as technology. One of the biggest arguments in favor of the black hole starship concept is that it's one of the only known methods of space travel that could theoretically allow a civilization to reach a significant fraction of the speed of light. This is important because, according to Einstein's theory of relativity, as an object approaches the speed of light, time slows down for those on board. This means that a civilization using a black hole starship could travel vast distances without experiencing the same passage of time as the rest of the universe. This effect, known as time dilation, means that for those inside the ship, a journey of thousands of years could feel like only a few decades. This could explain one of the biggest paradoxes in the search for extraterrestrial life, the Fermi paradox. If advanced civilizations are using black hole starships, they might not be detectable in the way we expect. Instead of sending radio signals or using conventional spacecraft, they might be operating on cosmic timescales, moving through the universe in ways we simply don't understand. Another possibility is that black holes could be used for computational purposes. Theoretical physicists have suggested that black holes could serve as natural quantum computers, capable of performing computations far beyond the reach of any technology we currently possess. If an advanced civilization has discovered a way to harness the computational power of black holes, they might not need traditional forms of space travel at all. Instead, they could be running complex simulations or even uploading their consciousness into black holes, effectively merging with the structure of the universe itself. But what would this mean for humanity? If we ever hope to build a black hole starship, the first step would be creating an artificial black hole. This is no small task, as even the smallest black holes we know of have masses several times that of the Sun. However, some theories suggest that it might be possible to create micro black holes using extremely high-energy particle collisions. These tiny black holes could, in theory, evaporate quickly due to Hawking radiation, but if we found a way to sustain them, they could be used as an energy source for propulsion. One idea is the black hole bomb, a concept in which energy is extracted from a rotating black hole using electromagnetic waves. If a spacecraft could harness this effect, it could generate propulsion without the need for traditional fuel. However, the engineering challenges of containing a black hole, safely extracting energy, and navigating through space with such a powerful object are beyond anything we can currently achieve. Despite the challenges, the idea of black hole starships remains one of the most compelling possibilities for deep space travel. If humanity ever reaches the point where we can manipulate gravity and control black holes, the universe could open up to us in ways we never imagined. We might discover that we are not the first civilization to attempt this, and that the answers to some of our biggest questions about the cosmos lie within these enigmatic objects. But there's one final, unsettling possibility. What if black holes are not just tools for travel, but also traps? Some physicists have speculated that if a civilization is not careful, attempting to use black holes for propulsion or energy could result in catastrophic consequences. If an artificial black hole were to become unstable, it could consume the very spacecraft that created it. This raises the question of whether any civilizations before us might have tried, and failed, to master black hole technology. If so, could we find evidence of their attempts? The more we learn about black holes, the more they seem to defy our understanding. They are not just cosmic voids. They are engines of destruction, potential sources of limitless energy, and possibly even gateways to other parts of the universe. If humanity can one day unlock their secrets, we might finally take our first real steps toward becoming an interstellar species. But until then, black holes remain one of the greatest and most mysterious frontiers in space exploration. Black holes challenge everything we know about physics, space, and time. They are the ultimate unknown, objects so extreme that even the laws of physics seem to break down near them. But what if they aren't just cosmic mysteries? What if they are the key to unlocking the universe? If black holes can be used for space travel, energy generation, or even computation, then they might not just be natural objects, they might be technological tools waiting to be discovered. One of the biggest questions is whether a civilization could actually construct a black hole. While naturally occurring black holes form from the collapse of massive stars, the idea of artificially creating one is something scientists have explored for decades. theoretical models suggest that extremely high-energy particle collisions, far beyond anything achievable in our current particle accelerators, could create micro-black holes. These would be tiny, potentially smaller than an atom, but still contain an immense gravitational pull. The problem is that micro-black holes, if they exist, would likely evaporate almost instantly due to Hawking radiation. To use a black hole for energy or propulsion, a civilization would need to either stabilize it or constantly generate new ones. One theory is that by feeding a black hole a controlled amount of energy, it could be sustained at a stable mass, allowing it to remain active indefinitely. This would require an understanding of gravity manipulation, something that currently exists only in the realm of theoretical physics. If a civilization could stabilize a black hole, they could theoretically use it in several ways. The first and most obvious use would be as a power source. A black hole can convert mass into energy with nearly perfect efficiency, far beyond anything possible with nuclear fusion. This means that if we could safely feed a black hole and extract the radiation it emits, we could have access to virtually unlimited energy. One of the most fascinating ideas is the concept of black hole propulsion. A spacecraft using this method would function by creating a controlled black hole behind it, and using the emitted radiation to push itself forward. This could allow for incredible acceleration without the need for traditional fuel. A ship like this wouldn't need enormous fuel tanks or massive engines. It would simply harness the energy of the black hole itself. But the real question is, could we actually travel at relativistic speeds using black holes? The answer is complicated. If a black hole starship could accelerate to a significant fraction of the speed of light, time dilation would come into effect. To passengers aboard the ship, a journey that might take thousands of years from an external observer's perspective could feel like only a few years. This means that for a civilization using black hole propulsion, interstellar travel might be far more practical than we currently assume. However, traveling at such high speeds introduces other challenges. Cosmic radiation, collisions with microscopic particles, and navigation through interstellar space all become serious concerns. At relativistic speeds, even a tiny grain of dust could cause catastrophic damage to a spacecraft. A ship using black hole propulsion would need an advanced shielding system to protect itself from interstellar debris. Some scientists have proposed electromagnetic deflector shields or even force fields to repel incoming particles before they can cause damage. But what if black holes could do more than just power starships? Some physicists believe that black holes could serve as natural quantum computers. The extreme conditions inside a black hole might allow for computational processes beyond anything we can currently achieve. This leads to the mind-bending possibility that advanced civilizations might not just be using black holes for travel, they might be uploading their consciousness into them. If this is true, then black holes could be more than just dead zones in space. They might actually be archives of entire civilizations, storing the knowledge and minds of ancient species that long ago abandoned physical existence. This would mean that when we observe black holes, we might not be looking at empty voids. We could be seeing massive cosmic computers, preserving the intelligence of past civilizations. But what would it take for humanity to achieve this level of technological mastery? The first step would be understanding gravity control. Right now, gravity is one of the least understood forces in physics. Unlike electromagnetism, which we can manipulate with ease, gravity remains beyond our control. If we ever hope to build black hole starships, we would need to find a way to generate and control artificial gravitational fields. One possibility is that an advanced civilization could create a synthetic event horizon, a structure that mimics the properties of a black hole without requiring a massive stellar collapse. If we could engineer something like this, it could serve as a prototype for future black hole propulsion systems. But there's an even bigger question. If black holes can be used for travel, are there civilizations already using them? If an advanced species has developed black hole technology, they might already be moving through the galaxy in ways we can't detect. Unlike conventional spacecraft, which emit heat, radiation, and light, a black hole-powered vessel would be almost invisible to our current detection methods. Some scientists have even speculated that rogue black holes, black holes that appear to be moving through space without an associated galaxy, could actually be artificial. If this is true, then we might already be observing alien megastructures, but because they resemble natural black holes, we don't recognize them for what they truly are. The idea of black hole starships is one of the most exciting and terrifying concepts in astrophysics. If we ever develop the ability to use black holes for space travel, it could open up the entire universe to us. But it also raises serious ethical and existential questions. What if something goes wrong? What if a black hole-powered civilization accidentally destroys itself? What if humanity tries to harness black holes before fully understanding the risks? The reality is, we are still in the very early stages of understanding black holes. But if we ever reach a point where we can control them, it will represent a turning point not just for space travel, but for the future of civilization itself. Black holes are the most extreme objects in the universe, and the idea of using them for space travel isn't just science fiction, it's a real possibility that could revolutionize humanity's understanding of movement through the cosmos. If we could harness a black hole's power, it would mean that our civilization could achieve speeds far beyond what's possible with traditional propulsion methods. It would mean that the biggest limitation to interstellar travel, the need for fuel, would be completely eliminated. But how could we actually build a black hole starship, and what would it take to make it work? One of the most promising concepts is the Hawking radiation drive. This idea is based on the fact that black holes slowly lose mass through a process called Hawking radiation. If a black hole were small enough, say, around the size of an asteroid, it would emit radiation at a rate that could be used for propulsion. Instead of burning fuel or expelling mass, a spacecraft using this method would simply direct the outgoing radiation, effectively riding the energy being released. This kind of system would provide an incredible thrust-to-weight ratio, meaning that even a relatively small black hole could power a spacecraft for an indefinite period of time. But the real challenge is creating and controlling such a black hole in the first place. A naturally occurring black hole is far too large to be used as a practical energy source. The smallest known black holes are several times the mass of the Sun, making them completely impractical for spacecraft propulsion. Instead, we would need to engineer a much smaller, artificial black hole. This could be done by compressing an enormous amount of energy into an extremely small space, something that is far beyond our current technological capabilities. Some scientists believe that high-energy particle collisions could produce primordial black holes, tiny black holes that formed in the early universe. If we could replicate the conditions of the Big Bang in a controlled environment, we might be able to create these black holes in a lab. The Large Hadron Collider has already tested for the existence of these micro black holes, though none have been found so far. However, if a future collider were powerful enough, it could theoretically produce stable black holes that could be harnessed for energy and propulsion. Once a black hole is created, it would need to be contained. This is where the concept of gravitational confinement comes into play. The idea is that an advanced civilization could construct an artificial structure around a black hole, effectively trapping it and using its energy output in a controlled manner. This could be achieved using magnetic fields, similar to how fusion reactors on Earth contain superheated plasma. If we could build a system capable of stabilizing a black hole, we could theoretically use it as a permanent energy source. But what happens when you actually try to pilot a black hole starship? The biggest issue is relativistic effects. As a ship powered by a black hole approaches the speed of light, time dilation kicks in. This means that time would pass much more slowly for the crew on board compared to an outside observer. A trip to another star system that takes thousands of years from Earth's perspective might only feel like a few years to the travelers. This has profound implications for space exploration. A civilization using black hole propulsion could effectively outpace time itself, allowing them to travel across the galaxy while experiencing only a few generations of their own history. This could mean that advanced extraterrestrial civilizations, if they exist, might not be bound by the same time constraints that we are. They might have already colonized the Milky Way but be moving so fast that we simply can't detect them. There's also the question of navigation. A black hole starship would need an incredibly advanced guidance system to avoid obstacles, gravitational distortions, and cosmic radiation. Unlike traditional spacecraft, which rely on thrusters for adjustments, a black hole-powered vessel would have to manipulate gravitational fields to steer itself. This could be done using carefully placed mass objects or by creating artificial gravitational wells that pull the ship in a desired direction. And then there's the possibility that black holes could be used for something even more radical, faster-than-light travel. While conventional physics tells us that nothing can travel faster than the speed of light, black holes might provide a loophole. Some theories suggest that black hole singularities could act as wormholes, creating shortcuts between distant parts of the universe. If this is true, then a black hole starship might not just be an engine, it could be a gateway. The implications of this are staggering. If an advanced civilization figured out how to use black holes as wormhole generators, they could create a vast network of interconnected star systems, effectively turning the galaxy into a highway system. This would make space travel instantaneous over vast distances, completely reshaping how we think about interstellar civilization. But what if black holes are already being used this way? Some scientists have suggested that rogue black holes that seem to be moving through space with no clear origin, could actually be artificial. If a civilization were using black holes for travel, these objects might be evidence of technological manipulation on a cosmic scale. This leads to an even bigger question. If black holes can be controlled, is there a way to communicate using them? Some physicists believe that black holes could serve as natural quantum computers, storing and processing information in ways we don't yet understand. This raises the mind-blowing possibility that black holes aren't just natural objects. They might be intelligent machines built by an advanced civilization. If this is true, then when we observe black holes, we might actually be looking at cosmic data centers, storing the knowledge of past civilizations. The information trapped inside a black hole's event horizon might not be lost. It could be encoded in a way that we just don't know how to read yet. This would mean that black holes are archives of the universe's history, containing the secrets of alien species, ancient knowledge, and even entire digital consciousnesses uploaded into the event horizon. But what does all of this mean for humanity? If we ever hope to reach this level of technological advancement, we will need to understand how to manipulate gravity itself. Right now, gravity is the least understood force in physics. Unlike electromagnetism, which we can control with ease, gravity remains a mystery. If we ever hope to build black hole starships, we must first unlock the secrets of gravitational engineering. This could mean discovering exotic matter, a type of material that interacts with gravity in ways we can't currently explain. Some theories suggest that dark matter, which makes up most of the universe's mass but is invisible to us, could hold the key to gravity manipulation. If we can figure out how to harness it, we might be able to bend space itself to create artificial gravitational fields. The concept of black hole starships is one of the most mind-bending ideas in modern astrophysics. If we can ever achieve this level of technological mastery, it would mean that humanity is no longer limited to its small corner of the galaxy. It would mean that the universe itself becomes our playground, and that the mysteries of space are no longer mysteries at all. But the question remains, are we ready for it? Harnessing the power of black holes is not just a scientific challenge, it's an existential one. If we get it wrong, we could destroy ourselves before we ever get the chance to explore the stars. If we get it right, we might just become the first civilization to unlock the true power of the cosmos. If humanity ever reaches the point of harnessing black holes for propulsion, we must first consider the immense energy requirements for creating and maintaining an artificial black hole. Theoretical studies suggest that a black hole small enough to be useful as an energy source would need to be around 1 billion tons in mass, compressed into a volume smaller than an atomic nucleus. The energy required to create such an object would be astronomical, far beyond anything we can currently achieve. Even the most advanced nuclear fusion or antimatter reactions pale in comparison to the energy densities needed. This suggests that, before humanity can ever dream of using black holes for interstellar travel, we must first unlock a deeper understanding of energy generation, potentially finding ways to tap into quantum vacuum energy, or other exotic forms of power that remain purely speculative. Once a black hole is created, containment becomes the next major challenge. A black hole has an immense gravitational pull, meaning that any material surrounding it would be instantly drawn toward its event horizon unless carefully balanced. One proposed method involves using high-energy electromagnetic fields to stabilize the black hole, similar to how magnetic confinement is used in experimental fusion reactors. If a sufficiently strong containment field could be developed, the black hole could be held in place, allowing its Hawking radiation to be harvested as a power source. This radiation, consisting of high-energy photons and other particles, could then be directed outward in a controlled manner, producing thrust. A spacecraft utilizing this principle would theoretically have an almost unlimited fuel source, limited only by the lifespan of the black hole itself. If the black hole were small enough, it would radiate energy at an extreme rate, but as it lost mass over time, its energy output would increase exponentially until it eventually evaporated. This means that a carefully engineered black hole would have to be constantly maintained at a precise mass to avoid burning out too quickly or failing to provide sufficient thrust. This delicate balance presents a significant engineering challenge, as even minor deviations in energy output could result in catastrophic failure. Beyond propulsion, black holes could serve another critical function in space travel, as sources of artificial gravity. Long-duration space missions face significant biological challenges due to microgravity. Prolonged exposure to weightlessness leads to muscle atrophy, bone loss, and other severe health effects. A black hole-powered spacecraft could theoretically generate artificial gravity by manipulating the intense curvature of spacetime around the black hole itself. By carefully positioning the black hole relative to the ship's structure, gravitational forces could be engineered to simulate Earth-like conditions, allowing for long-term human habitation without the detrimental effects of weightlessness. Another potential use for black holes in space travel is the possibility of energy harvesting on an interstellar scale. A sufficiently advanced civilization could surround a black hole with a Dyson-like structure, capable of absorbing and converting the emitted radiation into usable energy. Unlike conventional stars, which have finite lifespans, black holes can theoretically exist for trillions of years, providing a near-endless energy supply. This suggests that an advanced interstellar civilization might rely on black holes as power stations, strategically positioning them throughout the galaxy to serve as interstellar refueling hubs for spacecraft. Even more intriguing is the idea that black holes might be used for information processing. Some theories propose that the event horizon of a black hole could function as a kind of natural quantum computer, storing and processing information in ways that transcend our current understanding of physics. If this is the case, a sufficiently advanced civilization could encode vast amounts of knowledge within black holes, effectively using them as cosmic data storage units. This raises the possibility that naturally occurring black holes might already contain imprints of ancient civilizations, long-lost knowledge, or even entire artificial intelligences uploaded into their event horizons. The study of black holes also brings up questions about the fundamental nature of spacetime itself. General relativity suggests that black holes can warp and distort spacetime to an extreme degree, creating regions where time slows down or even stops entirely. This suggests that, under the right conditions, a spacecraft utilizing black holes could experience extreme time dilation, effectively allowing for a form of relativistic time travel. A crew traveling near a black hole could return from their journey to find that thousands, or even millions of years have passed on Earth. This raises profound questions about the long-term consequences of interstellar exploration and the nature of causality. There is also the speculative possibility that black holes could be linked to wormholes, theoretical structures that might allow for instantaneous travel between distant points in the universe. If a naturally occurring wormhole could be stabilized using exotic matter, it might be possible to use black holes as cosmic gateways, allowing for faster-than-light travel. While current physics suggests that naturally stable wormholes are unlikely, some theories propose that black holes with rotating singularities, known as Kerr black holes, could theoretically allow for traversal through a higher dimensional space. If this is the case, then a spacecraft capable of surviving the intense gravitational forces near a black hole might be able to enter one side and emerge on the other side of the galaxy, or even in an entirely different universe. This leads to the possibility that black holes are not merely natural objects but could serve as interstellar highways for advanced civilizations. If an extraterrestrial civilization has already mastered the manipulation of black holes, they might have constructed an entire network of artificial wormholes, allowing for near-instantaneous travel across vast cosmic distances. This raises the question of whether the unexplained motion of some black holes, particularly those found moving at high speeds through interstellar space, could be evidence of artificial manipulation. If black holes are being used in this way, it would suggest a level of technological advancement so far beyond human capabilities that it would be indistinguishable from magic. Some physicists speculate that black holes could even be used as weapons, capable of reshaping entire planetary systems. A sufficiently advanced civilization could theoretically direct a small black hole toward a hostile target, where its gravitational influence could destabilize planetary orbits, consume entire worlds, or trigger extreme tidal forces capable of rendering a planet uninhabitable. The ability to weaponize black holes would make them the ultimate tool of destruction, capable of annihilating entire civilizations without leaving a trace. But if black holes can be controlled, the real question is whether they can be created at will. If an advanced civilization has found a way to generate artificial black holes, it might mean that their entire technological infrastructure is built around them. Instead of relying on traditional energy sources, they might tap directly into the energy of spacetime itself, making them effectively omnipotent within the limits of physics. If such civilizations exist, they might be entirely unrecognizable to us, existing as massive Dyson-like structures orbiting artificial black holes. If black holes truly are the key to interstellar travel, then our future as a space-faring civilization may depend on our ability to unlock their secrets. Humanity currently lacks the technological capabilities to create, control, or manipulate black holes, but as our understanding of physics advances, the possibility of using them for propulsion, energy generation, and even communication becomes increasingly plausible. The first civilization to master black hole engineering would gain access to a level of power that could shape the fate of the galaxy itself. But as with any great power, the risks are just as immense. The ability to manipulate black holes could just as easily lead to destruction as it could to progress. If humanity ever reaches this level of technology, we must tread carefully, for even the slightest miscalculation could unleash forces far beyond our ability to control. The universe is governed by laws we are only beginning to understand, and the key to our survival may lie not in bending those laws to our will, but in learning to exist in harmony with them. Whether black holes will one day be the engines of our starships, the archives of our knowledge, or the gateways to other universes, one thing is certain: they remain among the most mysterious and powerful objects in existence. The path to mastering them will not be easy, but if we succeed, we may unlock the greatest secrets the cosmos has to offer. If black holes are the ultimate key to interstellar travel, then understanding their true nature is essential for advancing beyond the limits imposed by current physics. While we have observational evidence of black holes, and theories like general relativity describe their behavior with remarkable accuracy, the deeper question of what lies beyond the event horizon remains one of the greatest mysteries of modern science. One of the most perplexing aspects of black holes is the singularity, a point of infinite density at the core where all known laws of physics break down. According to general relativity, any object crossing the event horizon is inevitably pulled toward this singularity, where spacetime is infinitely curved. But quantum mechanics, which governs the smallest scales of reality, suggests that infinities cannot physically exist, meaning that our current understanding of black holes is incomplete. If we are to harness black holes for travel or energy, we must first reconcile these two fundamental pillars of physics, relativity and quantum mechanics, into a unified theory of quantum gravity. One promising avenue of exploration is the idea that singularities may not be true infinities but instead are hidden behind an event horizon due to quantum effects. Some theories suggest that singularities might be replaced by Planck stars, ultra-dense objects stabilized by quantum gravity effects. If this is the case, then black holes may not be as destructive as they appear, but instead could function as ultra-compact objects with exotic properties. This would open up the possibility of controlled interaction with black holes, making their use as energy sources or even space-time manipulation devices more feasible. Another key question is whether information that falls into a black hole is truly lost. The black hole information paradox arises because quantum mechanics dictates that information cannot be destroyed, yet classical physics suggests that anything crossing the event horizon is lost forever. Recent studies propose that black holes may encode information on their event horizons in a holographic manner, meaning that, in principle, the information that enters a black hole is not lost but is instead stored in a lower-dimensional representation on the horizon itself. If this is true, then black holes could function as vast cosmic archives, storing the history of the universe in ways that we are only beginning to comprehend. The possibility that black holes could store and process information leads to an even more profound idea, that they may be natural computers. Some physicists speculate that black holes could function as computational engines, capable of performing complex calculations at an efficiency far beyond any human-made machine. If a civilization could manipulate black holes at this level, they might be able to use them as cosmic-scale quantum computers, processing information at a rate that transcends anything imaginable with current technology. Such civilizations might be indistinguishable from the fabric of the universe itself, existing as vast networks of computational matter embedded within black hole event horizons. But if black holes can be used as cosmic archives or computers, then it raises another unsettling possibility. What if black holes are already being used for such purposes? If an advanced civilization had discovered how to encode information into black holes, they might have left behind vast data structures hidden within the event horizons of naturally occurring black holes. The signals we detect from black holes today, gamma-ray bursts, gravitational waves, and other high-energy phenomena, could potentially contain encoded information, waiting to be deciphered. This would imply that black holes are not just natural cosmic objects, but engineered artifacts left behind by ancient, hyper-advanced intelligences. Even more speculative is the idea that black holes could serve as gateways to other dimensions. Some interpretations of string theory suggest that black holes might be connected to higher dimensional spaces, known as branes, through which information, matter, or even entire universes could be exchanged. If this is the case, then it might be possible for an advanced civilization to use black holes as portals, accessing parallel universes or distant regions of our own universe. This concept aligns with the idea that some black holes could function as wormholes, offering a means of travel that circumvents the speed of light barrier imposed by relativity. The challenge, however, is that any object attempting to traverse a black hole's event horizon would face extreme tidal forces, known as spaghettification, which would stretch and tear it apart. Some theories propose that if a black hole is rotating fast enough, its singularity may take on a ring-like shape rather than a point, potentially allowing for safe passage through a hypothetical wormhole. This remains purely speculative, but if true, it could mean that naturally occurring black holes might already serve as cosmic shortcuts used by unknown civilizations. Beyond the theoretical implications of black holes, their practical applications remain daunting but potentially transformative. One proposed method of interstellar propulsion involves using a black hole as an energy source to drive a spacecraft forward. If a small, artificial black hole could be maintained within a containment field, its Hawking radiation could be directed in a specific direction, creating thrust. Theoretically, this could allow for near-light-speed travel, limited only by the energy constraints of maintaining and stabilizing the black hole. Another possibility is the use of black holes for power generation. A civilization capable of creating artificial black holes could use them as controlled energy sources, extracting power by feeding mass into them and harvesting the resulting radiation. This would provide an almost limitless energy supply, potentially sustaining entire planetary civilizations or deep space habitats for millions of years. If a civilization were able to manipulate black holes on a large scale, they might even use them to construct vast Dyson-like structures, absorbing and directing their energy output with incredible efficiency. But perhaps the most radical idea is that black holes might play a role in the fundamental structure of reality itself. Some theories propose that our own universe could be the interior of a higher dimensional black hole, meaning that what we perceive as the Big Bang was actually the formation of a black hole in another, larger cosmos. If this is true, then studying black holes might not only reveal the secrets of interstellar travel but could also provide insights into the nature of existence itself. If black holes are the key to unlocking the deepest mysteries of the cosmos, then the first civilization to master them will gain access to a level of power and knowledge beyond anything currently imaginable. But with great power comes great risk. The ability to manipulate black holes could just as easily lead to catastrophic destruction as it could to technological advancement. The gravitational forces involved are so immense that even a minor miscalculation could have universe-altering consequences. The journey to understanding black holes is still in its infancy, but each new discovery brings us closer to unraveling their secrets. Whether they become the engines of our starships, the libraries of our history, or the portals to other realms, one thing remains certain: black holes are among the most powerful and enigmatic objects in existence. The pursuit of their understanding will not only shape the future of space exploration, but may ultimately redefine our place in the cosmos itself. Black holes, as enigmatic and powerful as they are, remain one of the most perplexing frontiers in our understanding of the universe. But if there is even a slight possibility that they could be harnessed for interstellar travel, it forces us to reconsider everything we think we know about space, time, and even the limits of human potential. The very idea of using black holes as starships, or at the very least as stepping stones to a new era of exploration, opens doors to possibilities that blur the line between science fiction and reality. The first challenge, of course, is survival. The extreme gravitational forces near a black hole would make it nearly impossible for conventional materials to withstand the journey. Any spacecraft approaching the event horizon would experience a tremendous difference in gravitational pull between its front and back, causing it to stretch and eventually disintegrate. This phenomenon, known as spaghettification, means that even the most advanced spacecraft we can currently imagine wouldn't last long. But what if there were a way to counteract these forces? Some theorists suggest that if a spacecraft could generate an artificial gravitational field around itself, essentially creating a bubble of stable spacetime, it might be possible to navigate around or even into a black hole without being torn apart. This brings us to the concept of warp fields, which are often discussed in relation to faster-than-light travel. A warp drive, if it could be built, would create a localized distortion in spacetime, allowing a ship to move without actually accelerating in the traditional sense. If such technology were combined with black hole physics, a spacecraft might be able to hover at the very edge of the event horizon, using the immense gravitational pull as a slingshot to reach speeds far beyond what chemical or nuclear propulsion could ever achieve. But perhaps an even more mind-bending idea is the possibility of artificial black holes. Theoretically, if a civilization could generate a micro-black hole, a tiny but extremely dense object with its own event horizon, it could be used as a power source or even a propulsion system. A small, controlled black hole could emit Hawking radiation, and by carefully directing this radiation, it could generate thrust. This idea, sometimes referred to as the black hole rocket, would allow for constant acceleration without the need for massive fuel reserves, making it one of the most efficient propulsion systems imaginable. However, creating and containing a black hole, even a small one, presents its own set of challenges. The energy required to compress matter to such an extreme degree would be astronomical. And even if we could somehow produce one, keeping it stable and preventing it from consuming everything around it would be an almost insurmountable task. Some theories suggest that an advanced civilization might be able to manipulate space itself to generate artificial black holes in a controlled manner, but this is purely speculative. Then there's the question of navigation. If a spacecraft were to use black holes as a means of travel, whether by slingshotting around them or entering their event horizons, it would require a level of precision far beyond anything humanity has achieved. Even a tiny miscalculation could send a ship spiraling into oblivion. But if an advanced civilization had already mastered this kind of travel, they might leave behind navigational markers, gravitational anomalies, radiation patterns, or even artificial structures, hidden within the cosmic landscape, waiting to be discovered by those who come after them. Could such signs already be out there? Some researchers have speculated that certain unexplained cosmic phenomena, such as fast radio bursts, unusual gamma-ray emissions, or even the strange behavior of certain black holes, might be evidence of advanced extraterrestrial activity. While mainstream science remains skeptical, the possibility cannot be ruled out entirely. If a civilization had developed black hole technology, their engineering projects might be detectable across vast distances, appearing to us as anomalies that defy conventional astrophysical explanations. But what about the possibility that black holes are not just tools for travel, but destinations in themselves? Some theories propose that the interiors of black holes might not be the dead ends we assume them to be. Instead, they could contain entire new universes, with their own laws of physics and space-time structures. This idea, sometimes referred to as the black hole cosmology hypothesis, suggests that our own universe might have originated from a black hole in a parent universe. If this is true, then entering a black hole might not mean destruction, but rather passage into an entirely new realm of existence. The implications of this are staggering. If black holes are gateways to other universes, then they might be the key to a form of travel that transcends not just interstellar distances, but the very boundaries of our reality. Some physicists have even suggested that an advanced civilization could intentionally create black holes as a means of seeding new universes, effectively becoming cosmic architects on a scale beyond human comprehension. Even if we never reach the point of traveling through black holes ourselves, understanding their nature could still revolutionize our understanding of physics. The study of black holes has already led to major breakthroughs in quantum mechanics, relativity, and cosmology. The discovery of Hawking radiation, for example, provided one of the first clues that black holes are not entirely black, but rather slowly evaporate over time. This insight has led to new theories about the nature of information, entropy, and even the fabric of spacetime itself. And what if the true nature of black holes is even stranger than we imagine? Some speculative ideas suggest that black holes could be conscious in some way, complex computational entities that process information on a level beyond human understanding. While this might sound like science fiction, it is not entirely out of the realm of possibility. If black holes can encode vast amounts of information on their event horizons, could they also function as self-contained minds, thinking in ways that we cannot yet comprehend? If this is the case, then interacting with a black hole might not just be a physical challenge, but an intellectual one. Understanding the language of black holes, if such a thing exists, could be the first step in unlocking their secrets. Perhaps the ultimate test of an intelligent species is not just the ability to travel the stars, but the ability to communicate with the universe itself. As we continue to explore the mysteries of black holes, we are not just seeking new frontiers for space travel, we are searching for the fundamental truths of existence. Whether black holes become the engines of our interstellar voyages, the archives of our cosmic history, or the gateways to new realities, one thing is certain: they are far more than mere objects of destruction. They are the most fascinating and profound structures in the universe, and their true potential remains to be discovered. If black hole starships are even remotely possible, the key to making them work would likely lie in an advanced understanding of gravity manipulation. Right now, our best theories about gravity come from Einstein's general relativity, which describes it as the warping of spacetime by massive objects. But to truly harness black holes for space travel, we would need to go beyond our current knowledge. This would mean bridging the gap between general relativity and quantum mechanics, a feat that has eluded physicists for decades. One of the biggest questions is how to interact with a black hole without being destroyed. Traditional spacecraft would be torn apart by the extreme tidal forces near the event horizon. But if we could develop an advanced energy field, something akin to an artificial gravity shield, it might be possible to counteract these effects. This would work by generating a force that pushes back against the intense gravitational pull, effectively creating a stable pocket of space where a spacecraft could exist without being stretched into oblivion. This idea ties into theories about negative energy and exotic matter, both of which are central to concepts like the Alcubierre warp drive. Theoretically, negative energy could allow for the warping of spacetime in a way that lets a ship move faster than light without actually violating relativity. If a black hole starship were to function, it might require the same kind of energy manipulation to form a protective shell around itself, allowing it to safely navigate through the extreme gravitational environment. Another potential method for harnessing black holes involves what's known as the Penrose process. This idea, first proposed by physicist Roger Penrose, suggests that energy can be extracted from a rotating black hole by using its ergosphere, the region just outside the event horizon where spacetime itself is being dragged along by the hole's rotation. If a spacecraft could strategically drop and retrieve objects within this zone, it could generate a net energy gain, effectively using the black hole as a power source. This method could allow a ship to harness the rotational energy of a black hole without ever having to cross its event horizon. If a sufficiently advanced civilization mastered this technique, they might be able to build an entire propulsion system around it. A fleet of ships could operate in the vicinity of a supermassive black hole, constantly extracting energy and using it to propel themselves across the galaxy. This would eliminate the need for conventional fuel sources, making interstellar travel far more efficient. The larger the black hole, the more energy it would provide, meaning that civilizations might specifically seek out the biggest and most active black holes to use as weapons for their journeys. But what about artificial black holes? If creating a naturally occurring black hole is beyond our reach, could we instead engineer one? Some physicists have proposed the idea of microscopic black holes, tiny but incredibly dense objects that could, in theory, be created in high-energy environments. If we could somehow manufacture and control these black holes, they could serve as powerful energy sources or even compact propulsion units for interstellar travel. One idea is to use Hawking radiation, the theoretical process by which black holes slowly evaporate over time. If a small black hole were generating this radiation in a controlled manner, it could be directed outward as a highly efficient energy source, much like a nuclear reactor but far more powerful. This would provide continuous propulsion without the need for traditional fuel, making it one of the most efficient space travel methods ever conceived. However, controlling an artificial black hole is no small task. Even if we could create one, we would need a way to prevent it from growing uncontrollably or collapsing too quickly. This would require an unprecedented level of precision in energy manipulation, potentially involving technologies that don't yet exist, such as stable negative energy fields or highly advanced quantum containment structures. Another major question is how to navigate black holes safely. If black hole starships became a reality, would they simply orbit black holes, using them as power sources? Or would they actually attempt to enter them? If the latter, then we would need a completely new understanding of what happens inside a black hole. The conventional view is that crossing the event horizon means inevitable doom. Once inside, nothing can escape. But some theories suggest otherwise. For example, if black holes contain wormholes or hidden dimensions, it's possible that a spacecraft entering one might emerge somewhere else in the universe, or even in an entirely different universe. If this were the case, black holes could function as natural portals for intergalactic or interdimensional travel. Some physicists propose that the singularity at the center of a black hole, the point where gravity becomes infinite, might not actually be a true singularity. Instead, it could be a kind of bounce point, where matter and energy are compressed to an extreme degree before being released somewhere else. This idea aligns with certain interpretations of quantum gravity, which suggests that singularities might not actually exist in the way we currently think. If this is true, then entering a black hole might not mean destruction, but rather a transition to another region of space-time. The concept of black holes as wormholes has been explored in various theoretical models, including those inspired by the Einstein-Rosen bridge. This theory suggests that black holes and white holes, hypothetical objects that expel matter instead of absorbing it, could be connected, forming a tunnel through space-time. If such structures exist, they could be used as cosmic shortcuts, allowing for instantaneous travel across vast cosmic distances. Of course, the biggest challenge with this idea is stability. Most models suggest that natural wormholes would collapse almost instantly unless they were stabilized by exotic matter with negative energy density. If an advanced civilization had the means to produce and control such matter, they might be able to turn black holes into functional gateways rather than one-way trips to oblivion. Even if black hole starships never become reality, the pursuit of this technology would still revolutionize our understanding of physics. Exploring how black holes interact with matter and energy at extreme scales could lead to breakthroughs in everything from quantum mechanics to energy production. In fact, the study of black holes has already led to some of the most significant discoveries in modern physics, including the nature of quantum entanglement and the information paradox. One particularly intriguing possibility is that black holes themselves might store information in ways we don't yet fully understand. Some theories suggest that the surface of a black hole, the event horizon, acts like a cosmic hard drive, encoding everything that falls into it. If we could decipher this information, we might gain access to a hidden record of the universe's history, potentially unlocking secrets about the origins of the cosmos and the nature of reality itself. If a civilization were advanced enough to create artificial black holes, they might also be able to use them as vast information processing systems, essentially turning them into hyper-advanced computers. This idea, sometimes referred to as black hole computing, suggests that a sufficiently powerful black hole could function as an enormous quantum processor, solving complex problems beyond the reach of any conventional supercomputer. This raises an even more mind-bending question. Could an entire civilization exist inside a black hole? If black holes contain hidden dimensions or alternate realities, it's possible that advanced life forms might have evolved within them, completely separate from our own universe. If so, then black holes might not just be the engines of future space travel. They could also be home to civilizations beyond our imagination. If black hole starships are to become a reality, one of the most important factors to consider is how to generate and sustain a stable black hole for propulsion. Theoretically, there are two primary ways to approach this: using naturally occurring black holes or creating artificial ones. Both come with immense challenges and possibilities. A naturally occurring black hole, such as a stellar mass or supermassive black hole, could serve as an interstellar energy source if a civilization developed the technology to harness its rotational energy or Hawking radiation efficiently. A spacecraft could orbit the black hole at a carefully calculated distance, using energy extraction techniques like the Penrose process or Blandford's Najek mechanism to siphon power from the black hole's immense gravitational forces. The key challenge here is stability. Any miscalculation could send the spacecraft spiraling toward the event horizon, leading to its complete annihilation. The alternative is the creation of an artificial black hole, which presents a different set of difficulties. The most plausible method for generating a black hole on a manageable scale would be to compress matter to an extreme density, achieving what's known as the Schwarzschild radius, where the escape velocity equals the speed of light. Some speculative theories suggest that high-energy particle collisions, such as those occurring in particle accelerators or during gamma-ray bursts, could momentarily form tiny black holes. However, these would typically evaporate almost instantly due to Hawking radiation unless a way to stabilize them was found. One of the most promising theoretical models for an artificial black hole involves the concept of a Kugelblitz, a black hole formed entirely from concentrated energy rather than matter. According to general relativity, if a sufficient amount of energy is compressed into a small enough volume, it could collapse into a black hole just as physical mass does. If a civilization could develop an energy containment system capable of focusing an immense amount of radiation into a single point, it might be able to create a controlled Kugelblitz black hole. A Kugelblitz propulsion system would work by continuously feeding energy into the black hole, maintaining its stability while harnessing its Hawking radiation for thrust. This would create an incredibly efficient propulsion system, as the energy output of even a small black hole could be orders of magnitude greater than any conventional fuel source. The challenge, of course, would be ensuring that the black hole remained contained and did not either grow uncontrollably or evaporate too quickly. Theoretically, a spacecraft using a controlled black hole as its primary energy source could achieve near-light speeds, potentially making interstellar travel feasible within a human lifespan. The propulsion system would function similarly to a nuclear rocket, but instead of fission or fusion reactions, it would rely on the immense energy output of a black hole. The emitted Hawking radiation could be directed backward as exhaust, creating thrust while simultaneously preventing the black hole from evaporating too quickly. For intergalactic travel, a civilization would need to develop advanced methods of navigating the gravitational complexities of black hole propulsion. Unlike traditional propulsion systems, which operate within the relatively straightforward Newtonian mechanics of space travel, black hole starships would need to account for extreme relativistic effects. Time dilation would become a significant factor, meaning that while the crew of the ship might experience a journey lasting only a few years, thousands of years could pass for observers outside the black hole's influence. Additionally, radiation shielding would be a major concern. Black holes emit intense radiation in the form of Hawking radiation, gamma rays, and other high-energy particles. Without sufficient protection, the crew of a black hole-powered ship could be subjected to lethal doses of radiation. Advanced shielding technologies, possibly involving electromagnetic fields or exotic materials with quantum-level radiation absorption properties, would be necessary to ensure the safety of interstellar travelers. Another significant challenge would be maintaining control over the black hole itself. In theory, the black hole would need to be contained within an artificial structure, perhaps a spherical shell of exotic matter capable of resisting immense gravitational forces. If this shell were even slightly compromised, the black hole could either collapse in on itself or begin consuming surrounding material uncontrollably, leading to catastrophic failure. A potential solution to this issue could be the use of a dynamic containment field, an advanced form of electromagnetic or gravitational manipulation that could adjust in real time to stabilize the black hole's energy output. If a civilization mastered this technology, it could fine-tune the energy output of the black hole, allowing for precise control over propulsion, acceleration, and deceleration. One particularly intriguing possibility is the use of multiple black holes in tandem. Instead of relying on a single artificial black hole, an advanced civilization might construct a binary or even ternary system of black holes, using their gravitational interactions to optimize propulsion and maneuverability. A network of carefully positioned black holes could act as a gravitational catapult, flinging a spacecraft across vast cosmic distances with minimal energy expenditure. There's also the question of what happens if a black hole starship were to enter another black hole. If the theory of wormholes holds true, then entering a black hole might not mean destruction but rather a transition to another region of the universe, or even another universe entirely. If so, black hole starships might not just be a means of traveling between stars, but a gateway to entirely new realms of existence. This brings us to the concept of black holes as cosmic transportation hubs. If a sufficiently advanced civilization could stabilize and manipulate wormholes, they might establish a network of black hole gateways, allowing for nearly instantaneous travel between distant galaxies. Instead of conventional starships, civilizations might deploy autonomous probes designed to seek out and stabilize naturally occurring wormholes, creating a vast cosmic transportation system. However, the stabilization of a wormhole would require exotic matter with negative energy density, something that has only been theorized in quantum physics. If a civilization discovered a way to generate or harness negative energy on a large scale, it might be able to create artificial wormholes, linking different points in space and enabling travel on an unprecedented scale. At the highest levels of technological advancement, a civilization might go beyond using black holes for propulsion and instead integrate them into their very structures. Some speculative models suggest that a civilization capable of harnessing black holes might construct vast megastructures around them, using their immense energy output for everything from computing to artificial ecosystems. If such a civilization existed, they might be indistinguishable from black holes themselves. Instead of conventional planets or spacecraft, they might inhabit structures that are gravitationally bound to black holes, feeding off their energy while remaining hidden from external observation. This leads to the hypothesis that some black holes we observe today might not be purely natural phenomena, but rather the remnants of highly advanced civilizations that have transcended conventional matter-based existence. The idea of civilizations evolving to integrate black holes into their very fabric raises profound questions about the nature of intelligence and technological progression. If black holes represent the ultimate energy source and information storage system, could an advanced civilization eventually transition into a form of existence that is fundamentally tied to them? Could black holes themselves be a kind of cosmic archive, preserving the knowledge and essence of civilizations that have come before? The pursuit of black hole starships is not just about space travel, it's about unlocking the deepest secrets of the universe. Whether or not humanity ever builds such a vessel, the journey of understanding black holes will likely lead to profound discoveries about the nature of reality, the limits of physics, and the potential of intelligent life beyond Earth. If a civilization were to master the use of black holes for space travel, it would inevitably lead to an entirely new framework for understanding propulsion, energy generation, and even the fundamental nature of space and time. The existence of a black hole starship would mean that energy production had reached levels far beyond anything humanity currently comprehends. More importantly, it would mean that a civilization had discovered ways to manipulate spacetime itself in ways that defy our current limitations. One of the greatest theoretical advantages of a black hole propulsion system is its nearly unlimited energy potential. Unlike chemical rockets, which require vast amounts of fuel to generate relatively small amounts of thrust, or even nuclear fusion, which is incredibly efficient but still relies on physical matter as a fuel source, a black hole starship could function for millennia without the need for traditional refueling. The Hawking radiation emitted by a microscopic black hole would provide a continuous and powerful source of energy, allowing a spacecraft to accelerate indefinitely, at least until relativistic effects and interstellar medium interactions imposed practical limitations. However, maintaining control over such a propulsion system introduces new challenges. The stability of an artificial black hole would require precise energy input to counteract the natural evaporation predicted by Hawking radiation. If too much energy were absorbed or lost too quickly, the black hole could either collapse entirely or expand beyond safe limits, potentially consuming the very vessel it was designed to propel. The civilization developing this technology would need to master an advanced understanding of quantum gravity, a field that currently remains one of the biggest unsolved problems in physics. Beyond propulsion, black hole starships raise deeper questions about navigation and time dilation. Unlike traditional spacecraft, which move through space in a relatively straightforward manner, a black hole-powered vessel would experience extreme relativistic effects as it approached a significant fraction of the speed of light. The closer it got to this limit, the more time would slow down for those aboard relative to the rest of the universe. A journey that might feel like months to the crew could span thousands, or even millions of years for those outside the ship. This has profound implications for interstellar exploration. A civilization using black hole propulsion would need to account for the fact that any mission to a distant star system might return to a home world that had changed beyond recognition, or perhaps ceased to exist altogether. This raises the question of whether such a civilization would even rely on physical explorers at all. Instead of manned starships, they might deploy autonomous artificial intelligence systems capable of navigating the complexities of black hole travel while transmitting data back across cosmic distances. Additionally, black hole starships introduce the possibility of new forms of interstellar communication. Instead of using conventional electromagnetic signals, which degrade over vast distances and take years or centuries to traverse space, a sufficiently advanced civilization might develop methods of encoding information into the very fabric of spacetime itself. If black holes can serve as gravitational wave generators, then information might be transmitted almost instantaneously through controlled distortions in spacetime. This leads to one of the most intriguing possibilities: the use of black holes as a means of accessing other dimensions. Some theories in quantum gravity suggest that black holes might serve as bridges between different regions of the universe, or even different universes entirely. If a civilization had developed the means to manipulate black holes with precision, they might not just use them for propulsion, but as gateways to entirely new realms of existence. If this is the case, then black hole starships might not just be tools for traveling across space, but instruments for exploring the fundamental structure of reality itself. Instead of viewing space travel as a means of reaching new planets, such a civilization might see it as a way of uncovering the deeper layers of the cosmos, perhaps even discovering that our own universe is just one of many in a vast and complex multiverse. If we consider the long-term implications of such technology, it's possible that a sufficiently advanced civilization might eventually transcend physical existence as we understand it. If black holes can store vast amounts of information, then they might serve as the ultimate computational devices, capable of running incredibly advanced simulations. If a civilization integrated itself with a black hole-based computing structure, it might no longer need physical bodies or material resources. It could exist as pure information, encoded into the gravitational fabric of a black hole itself. This raises the question, could such civilizations already exist? If black hole starships, or even entire black hole-based civilizations, are a natural stage of technological progression, then it's possible that we are surrounded by them without realizing it. Some physicists have speculated that certain anomalies in the behavior of black holes could be evidence of artificial manipulation. If an advanced civilization has found a way to harness the power of black holes, it might be indistinguishable from the natural cosmic processes we currently observe. This ties into the concept of the black hole hypothesis for advanced civilizations, which suggests that truly advanced extraterrestrial civilizations might be unobservable because they have evolved beyond the need for visible structures or energy emissions. Instead of vast Dyson spheres or megastructures, they might exist as entities integrated into the very framework of black holes, manipulating their properties to exist outside of conventional spacetime. If this is the case, then black hole starships might not just be a theoretical possibility, they might already be in use, hidden within the very celestial objects we study. Perhaps the ultimate question isn't whether we can build such a vessel, but whether someone else already has. If an advanced civilization has already mastered black hole starship technology, what evidence would we look for? The challenge is that black holes are, by nature, difficult to observe. Their gravitational pull is so strong that not even light can escape, meaning any artificial structures or energy signatures near them would be hidden from direct detection. However, there are indirect clues that might hint at their existence. One possibility is unexplained energy fluctuations. A black hole starship would likely involve highly controlled manipulation of Hawking radiation, meaning that its energy emissions might not match the standard theoretical models of naturally occurring black holes. If astronomers were to observe a black hole with unusual radiation patterns or anomalous jets of matter behaving in unexpected ways, it could indicate artificial engineering at play. Another potential clue is the movement of black holes themselves. Natural black holes typically follow predictable orbital paths based on gravitational interactions with nearby stars and galaxies. If we were to detect a black hole accelerating or changing direction in ways that defy normal astrophysical processes, it might suggest external influence, perhaps even propulsion. A civilization capable of controlling the trajectory of a black hole would possess technology beyond anything we can currently comprehend. The possibility of detecting black hole starships also intersects with the ongoing search for extraterrestrial intelligence. The Fermi paradox. The question of why we haven't yet detected alien civilizations despite the vast number of potentially habitable planets might be partially explained if the most advanced civilizations have moved beyond traditional means of space travel and communication. If a species can harness the energy of black holes, they might have little need for conventional planetary colonization or radio signals, making them nearly impossible for us to detect with current methods. But let's consider what it would take for humanity to reach this level of technological advancement. If we wanted to create a black hole starship, the first challenge would be generating and containing a microscopic black hole. Some theories suggest that tiny black holes could be created in high-energy particle collisions, but sustaining and controlling one would require an unprecedented level of engineering precision. Even if we succeeded in creating a stable artificial black hole, the next hurdle would be finding a way to extract energy from it efficiently. Hawking radiation, while theoretically powerful, is incredibly weak for black holes of stellar mass. A black hole small enough to emit useful amounts of radiation would need to be constantly maintained to prevent it from either evaporating too quickly or growing uncontrollably. This would require technology far beyond our current capabilities. Perhaps some form of negative energy manipulation, exotic matter, or quantum field control. Then there's the question of navigation. A black hole-powered spacecraft would likely reach relativistic speeds, meaning that even tiny particles in space could pose a catastrophic risk. At near-light speeds, even a grain of dust would carry enough kinetic energy to cause massive damage. Any civilization using black hole propulsion would need advanced shielding mechanisms, possibly force fields, deflector screens, or some means of altering the local fabric of spacetime to avoid collisions altogether. The long-term implications of black hole travel are even more mind-bending. If a civilization masters this technology, they might not just use it for interstellar travel, they could begin altering spacetime itself. The ability to create and control black holes could lead to artificial wormholes, allowing instant travel across vast cosmic distances. In this scenario, space travel as we currently understand it would become obsolete, replaced by near-instantaneous movement between star systems, galaxies, or even alternate universes. Some physicists have speculated that if black hole manipulation is possible, it could lead to the creation of artificial universes. A sufficiently advanced civilization might generate a controlled singularity, using it to spawn an entirely new cosmos with different physical laws. If this is true, then our own universe could, in theory, be the result of an ancient civilization that reached this stage of technological evolution and decided to create a new realm of existence. The sheer scale of what black hole technology could enable forces us to rethink our place in the cosmos. If other civilizations have already reached this level, they might exist beyond our ability to detect or comprehend. Instead of searching for radio signals or megastructures, we might need to look at the very nature of black holes themselves for signs of artificial influence. Could some of the black holes we observe actually be functioning starships, moving across the galaxy with civilizations hidden inside them? Could they be engineered gateways to other parts of the universe, or even evidence of civilizations transitioning into post-physical existence? If humanity ever develops the ability to harness black holes, it will mark a turning point in our evolution. No longer bound by planetary constraints, we would become a truly interstellar species, capable of manipulating the most extreme forces in the universe. Whether we use this power for exploration, survival, or something even more profound remains an open question. But one thing is certain: if black hole starships are possible, they represent the ultimate leap forward in space travel, redefining what it means to journey through the cosmos. If we consider the possibility that black hole starships already exist somewhere in the universe, we have to ask ourselves, what would they look like? Unlike traditional spacecraft, which have engines, fuel tanks, and rigid structures, a black hole starship would be something far stranger. It wouldn't need massive chemical thrusters or ion drives. Instead, its main feature would be a highly controlled artificial or naturally captured black hole, surrounded by a sophisticated energy harvesting system. This system would need to capture Hawking radiation and convert it into usable thrust, heat management, and possibly even artificial gravity for whatever inhabitants or machinery are inside. One of the most interesting aspects of a black hole starship is that it doesn't require reaction mass in the same way conventional propulsion systems do. Traditional spacecraft, like our current rockets, need to eject mass to generate thrust. This is a fundamental limitation of rocketry. Eventually, you run out of fuel. But a black hole drive, if engineered correctly, could operate on an entirely different principle. By carefully directing the energy output of Hawking radiation and using it to create momentum, such a ship could, in theory, travel indefinitely as long as it had a method to maintain the black hole. Theoretically, such a starship could reach relativistic speeds, meaning a significant percentage of the speed of light. At these speeds, time dilation would become an important factor. Time would slow down for those aboard compared to the outside universe. This means that while thousands or even millions of years might pass for observers on Earth, only a few decades might pass for travelers on a black hole starship. This effect could allow a civilization to journey across vast cosmic distances without experiencing time in the same way as the rest of the universe. However, one of the biggest challenges with such a starship is control. Black holes are incredibly difficult to manipulate. The gravity they exert is extreme, and any miscalculation in handling them could be catastrophic. If a civilization were to construct a black hole drive, it would need a way to precisely control the size and mass of the black hole. Too large, and it could collapse into an uncontrollable singularity. Too small, and it might evaporate before it can be used effectively. The civilization operating it would need an advanced understanding of quantum mechanics, gravitational physics, and energy manipulation that far exceeds anything we currently possess. Another issue is shielding. At relativistic speeds, even tiny particles in interstellar space become highly dangerous. A single proton traveling at near light speed can carry enough energy to cause radiation damage. If a black hole starship were to travel through interstellar space, it would need a shielding system that could deflect or absorb these particles before they could cause harm. Some theories suggest that an electromagnetic or plasma-based shielding system could work, while others propose using a forward-facing magnetic field to sweep particles away before they hit the ship. But what if a civilization didn't just use black holes for propulsion? What if they built entire space habitats around them? If a black hole can provide an immense and nearly limitless source of energy, it could serve as the foundation for a Dyson sphere-like structure, a megastructure designed to harness all of the radiation output from the black hole. This could provide power for an entire civilization, allowing them to exist independently of any home planet. There is also the possibility that a highly advanced civilization could use black holes not just for travel, but for computation. Theoretical physicists have suggested that black holes might be capable of storing and processing information in ways we don't yet fully understand. If this is true, then a civilization could use black holes as hyper-efficient computers, running massive simulations or even uploading consciousness into them. In fact, some fringe theories suggest that we might already be inside a simulation running on such a system. If black holes can store and process vast amounts of information, then an advanced civilization might have created artificial universes within black hole computers, perhaps even entire realities indistinguishable from our own. Could our own universe be the result of such an experiment? This raises profound questions about the nature of existence and intelligence in the cosmos. If civilizations can manipulate black holes, they might not need planets, solar systems, or even physical bodies anymore. They could become beings of pure information, existing inside artificially created universes, evolving beyond anything we can comprehend. If black hole starships exist, they would likely be the work of civilizations that are millions or even billions of years ahead of us. Perhaps the reason we haven't found any evidence of extraterrestrial life is because they have already transitioned to a completely different form of existence, one that doesn't rely on traditional technology or planetary colonization. But what about the ethical implications of using black holes for travel? Would a civilization ever risk something so dangerous? The manipulation of black holes could have unintended consequences. Accidentally creating one too large could lead to devastation, while miscalculations in energy output could cause uncontrolled radiation bursts. A black hole starship might also pose a risk to any planets or star systems it passes through. The gravitational influence of even a small black hole could disrupt planetary orbits, leading to catastrophic consequences for any nearby civilizations. If humanity ever reaches the stage where we can create and control black holes, we will be faced with a choice. How do we use this power responsibly? Will we venture into the cosmos as explorers, harnessing black holes to reach distant stars? Or will we retreat inward, using black holes to create artificial realities where we can exist indefinitely, free from the limitations of the physical universe? One thing is certain: black hole starships, if they ever become reality, would represent the most significant leap in space travel ever conceived. They would push the boundaries of what is possible, allowing civilizations to cross the galaxy, transcend time, and perhaps even rewrite the very nature of reality itself. If a civilization were to build a black hole starship, the level of engineering required would be beyond anything we can currently imagine. The question then becomes, how would they create and sustain such a system? One possibility is the artificial creation of micro black holes. According to some theories, it might be possible to generate small black holes using incredibly high-energy particle collisions, perhaps through an advanced particle accelerator far beyond the scale of anything on Earth. If a civilization had the technology to produce black holes with a mass small enough to be contained and controlled, they could, in theory, use them as power sources and propulsion systems. The creation process, however, is only the first challenge. A black hole that is too small would evaporate almost instantly due to Hawking radiation. To be useful for propulsion, a black hole must be carefully maintained at an optimal size where its radiation output is powerful enough to provide thrust but not so intense that it becomes uncontrollable. This means there must be a method to continuously feed the black hole, adding mass when necessary to keep it stable. Some theorists suggest that an advanced civilization could use controlled streams of matter or energy fields to regulate the black hole's mass, preventing it from either shrinking to nothing or growing into a catastrophe. But assuming a civilization has mastered black hole containment and energy harvesting, the next challenge is navigation. How do you steer a starship that is essentially a miniature black hole? Traditional propulsion methods rely on directed force, but a black hole doesn't have physical thrusters. Instead, one proposed method involves asymmetrically directing Hawking radiation. If a civilization could precisely control the radiation emission using advanced electromagnetic fields or gravitational lensing, they could create directional thrust. This would allow them to push the starship in specific directions without needing to eject mass like a conventional rocket. This kind of precision control would require an understanding of quantum gravity far beyond our current knowledge. The ability to manipulate spacetime itself would likely be a prerequisite for steering a black hole-powered vessel. This suggests that any civilization capable of building such a starship would not only be technologically advanced but would also have a deep mastery of the fundamental forces of the universe. Another crucial factor is energy management. Black holes, even small ones, release an enormous amount of energy. The energy emitted through Hawking radiation could reach temperatures hotter than the core of a star. Without proper heat dissipation mechanisms, anything near the black hole would be vaporized. The ship would need a highly efficient system for managing heat, possibly using reflective surfaces, heat sinks, or even an active cooling mechanism involving exotic matter. But what if a civilization didn't stop at just using black holes for travel? What if they took it a step further and used them to manipulate spacetime itself? One of the most intriguing possibilities is that black holes could serve as a means of faster-than-light travel, not by directly exceeding the speed of light, but by bending spacetime in ways that create shortcuts. Theoretical constructs like Einstein-Rosen bridges, also known as wormholes, suggest that black holes could be used to link distant points in space. If a civilization could stabilize a wormhole using exotic matter, they might be able to create a network of cosmic highways, allowing instant travel between different parts of the galaxy. However, the physics of wormholes is highly speculative. Most calculations suggest that naturally occurring wormholes, if they exist, would be unstable and collapse instantly. But an advanced civilization might have the capability to reinforce a wormhole structure using negative energy, or some other unknown mechanism. If black hole technology were combined with wormhole stabilization, it could redefine space travel as we know it. And what about communication? If black holes can manipulate information, could they also be used as intergalactic transmitters? Some scientists propose that civilizations might use black holes as beacons, encoding messages into the radiation they emit. This would be a form of communication that operates on a cosmic scale, allowing messages to be sent across vast distances with minimal loss of information. If we ever detect unusual radiation patterns from distant black holes, it could be a sign that an advanced civilization is attempting to communicate. There's also the mind-bending idea that black holes could be used for time travel. The extreme gravitational effects near the event horizon create intense time dilation, meaning that time passes much more slowly for someone near the black hole than for an outside observer. This means that, in a way, a black hole starship could be a kind of time machine. If travelers aboard such a ship spent only a few years in their own time, they could return to find that thousands or millions of years had passed elsewhere in the universe. This raises philosophical and ethical questions. If a civilization embarked on a journey using black hole propulsion, would they ever be able to return to the same version of their home planet? Would they be explorers, or would they become lost to time itself? Even more extreme is the possibility that black holes could allow access to entirely different universes. Some theories suggest that black holes might not just be singularities but gateways to other realities. If this is true, then a sufficiently advanced civilization could use black holes not just for travel within our universe but for traveling between universes. This would completely change our understanding of existence, opening the possibility that civilizations don't just expand across galaxies but across multiple dimensions of reality. If black hole starships exist, we have to consider whether we might ever detect them. A ship using Hawking radiation for propulsion would likely emit high-energy radiation that could be visible to our telescopes, though distinguishing it from natural black holes would be difficult. Some have speculated that unexplained gamma-ray bursts, which are some of the most energetic events in the universe, might be linked to advanced propulsion systems, though no evidence currently supports this. And what if such ships have already passed through our solar system? If an advanced civilization were traveling between the stars using black hole technology, would we even recognize their presence? Unlike conventional spacecraft, which leave chemical trails or radio signals, a black hole starship might appear as nothing more than a faint gravitational anomaly, something easily overlooked unless we knew exactly what to look for. The idea of black hole starships forces us to reconsider what is possible. If such technology can exist, then it challenges many of our assumptions about space travel, energy generation, and even the nature of intelligence. The civilizations that could build them would be operating on a scale that makes even our most advanced technologies look primitive. They wouldn't just be explorers, they would be masters of gravity, energy, and time itself. And that brings us to the final question: if black hole starships are possible, why haven't we seen them? Are they rare? Are they hiding? Or are they simply so far beyond us that we can't even recognize them? If a civilization had truly mastered black holes, they might not need planets, stars, or even a conventional physical form. They might exist in ways we can't comprehend, operating on cosmic timescales and traveling through the universe in ways we haven't even begun to imagine. Perhaps the greatest mystery isn't whether black hole starships are possible, but whether we are even capable of understanding the civilizations that might use them. If we ever encounter such a civilization, will we recognize them? Or would they be so advanced that they seem like natural phenomena to us, unseen, unrecognized, and far beyond our grasp? If black hole starships exist, they would fundamentally change the way we think about interstellar travel, energy, and even the limits of intelligence itself. A civilization capable of harnessing a black hole would not just be advanced, they would be operating on a level that blurs the line between physics and engineering, between reality and what we currently consider impossible. But beyond just their existence, the real question is, what would they do with such power? One possibility is that a black hole starship would not simply be a vessel, but an entire self-sustaining world. If a civilization could control a black hole, they might construct an artificial habitat around it, using its radiation to power their entire society. This would be a civilization that no longer relied on a star for energy. Instead, they would have built their own gravitational well, existing independently of planetary systems. Such a structure could function for millions or even billions of years, completely self-sufficient, immune to the death of stars and the changing conditions of galaxies. These starships might be vast megastructures, possibly even resembling Dyson spheres or Dyson swarms, designed to orbit and harness the energy of a controlled black hole. Instead of conventional space stations, they would be gravitationally bound superstructures, engineered with precision to balance the immense forces at play. If such civilizations exist, they might be able to move entire habitats through space, migrating across the cosmos at speeds limited only by the constraints of relativity, or potentially beyond them if they have found ways to manipulate spacetime itself. The implications of such technology are staggering. If black hole starships are possible, then civilizations using them might be effectively immortal. Unlike species dependent on planets, which are vulnerable to extinction events, environmental changes, and cosmic disasters, a civilization that exists in a mobile black hole habitat could evade threats entirely. They could move away from supernovae, escape galactic collisions, and even traverse intergalactic space, surviving indefinitely. But what would be their purpose? If a civilization had achieved this level of technological mastery, what would they seek? Would they still be explorers, driven by curiosity? Or would they have transcended the need for exploration altogether? Some theories suggest that highly advanced civilizations may not be interested in expansion in the way we imagine. Instead of colonizing planets or conquering galaxies, they might be focused on entirely different objectives, perhaps manipulating the very fabric of the universe, searching for higher dimensions, or even attempting to rewrite the fundamental laws of physics. One possibility is that these civilizations are engaged in large-scale cosmic engineering projects. If they can manipulate black holes, they might be working on something far beyond simple travel. Some theorists have speculated that an advanced species might attempt to create new universes, using black holes as the seeds for entirely new realms of existence. The idea, known as cosmological natural selection, suggests that new universes could be generated through black holes, and an intelligent species might deliberately engineer them to have favorable physical laws. This would mean that some of the black holes we observe today could actually be artificial, created with the intention of spawning new universes. If black hole starships exist, another question arises: are they detectable? A civilization using a black hole for propulsion would generate enormous amounts of energy, likely emitting gamma rays, X-rays, and other high-energy signals. Yet, if they are sufficiently advanced, they might have developed methods to mask these emissions. Just as we use stealth technology to hide aircraft, an advanced civilization might have found ways to cloak their movements, making their ships indistinguishable from natural cosmic phenomena. This leads to a more unsettling possibility. What if we have already seen them but didn't recognize them? Could some of the black holes we observe in deep space actually be artificial? Could some of the unexplained energy signatures detected by our telescopes be the byproducts of an advanced propulsion system? If a civilization had the ability to manipulate black holes, they might be capable of hiding in plain sight, blending their energy emissions with the cosmic background radiation. And if they exist, what would happen if we encountered them? Would they communicate? Would they even acknowledge us? A civilization capable of building black hole starships might be so advanced that they view us the same way we view microbes, an interesting curiosity, but not something worth interacting with. If they are traveling through the universe on timescales of millions or billions of years, their perception of time and space would be completely different from ours. They might not even see us as relevant. But what if they did make contact? The consequences of encountering such a civilization would be beyond anything humanity has ever experienced. Our understanding of physics, technology, and even the nature of existence would be completely rewritten. We might gain knowledge that allows us to leap forward thousands or millions of years in our own development. Or we might realize that we are far more primitive than we ever imagined, standing at the very bottom of a cosmic hierarchy. If they have chosen to remain hidden, is it because they are waiting for us to reach a certain level of advancement? Or is it because they have no interest in interacting with civilizations at our stage? The Fermi paradox, the question of why we haven't detected extraterrestrial life, becomes even more profound when considering black hole starships. If there are civilizations capable of traveling with such technology, why haven't we seen clear evidence of them? Are they avoiding us? Are they bound by some universal law that prevents contact? Or have they simply moved beyond the need to engage with beings like us? And perhaps the most intriguing possibility of all, what if they are not separate from us, but are instead our future? If technological progression continues, could humanity one day build black hole starships of our own? Could we eventually abandon planets and stars, choosing instead to exist in the vast emptiness of space, powered by controlled singularities? If such a future is possible, then perhaps the civilizations using black hole technology today are simply earlier versions of what we might become. If black hole starships exist, then the universe is far stranger than we ever imagined. They could be drifting through space right now, invisible to us, following trajectories calculated millions of years ago, on journeys we cannot comprehend. They might be watching, waiting, or simply moving through the cosmos with no regard for life as we know it. If we ever find proof of their existence, it won't just change our understanding of space travel, it will change our entire place in the universe. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.